Chris. Good afternoon, everybody. I'm lucky because I have the only non-technical presentation, so it will be quite fast from my side. So I am Patrick Milin. I am a project manager at NG Lab Crigen, one of the R&D center of the NG group. And my activity focus on the adaptation and preparation of the natural gas appliances to the next, I would say, energy landscape, and the sector coupling and the different variety of gas quality on gas sources. So I am the coordinator of the THyGA project. I will show you in a few, on a few slides what are our goals and targets, on a few elements on our organization, so that you have the global vision of the project, even if most of you know about it. To introduce Jean Schweitzer and Chris DeWitt's presentation on work package 3 and 4. So Alexandra, if you can go to the next slide, please. All right, so the THyGA project is a Horizon 2020 project. So we are subsidized by the European Commission and the FCH JU to help to close knowledge gaps regarding the blends of hydrogen and natural gas for end-use appliances on residential and commercial sectors. So we are there to support the industry and the stakeholders and to give some answers to the, I would say, the states and the European Commission. So we are 9 partners in the consortium. We are 5 laboratories that will focus on combustion tests. DGC in Denmark, GVI and EBI in Germany, GasBE in Belgium, and NG in France. We also have a CEA in France, which is in charge of some aspects linked to non-combustion impact, for example, permeability or leakage. Then we have 2 manufacturers that are there to ensure that the work we are doing in the project is relevant for the industry and the manufacturers. We have BGA Thermea Group and Electrolux. And finally, the GURG, which is hosting this workshop, is in charge of topics related to communication, exploitation, and dissemination. Can we go to the next slide? Thank you. So in summary, the goals of the project is to, as I said before, to close the knowledge gaps regarding the impact of the blends on end user appliances. So the main focus in our case is to look into impact on combustion related scenarios for different kinds of appliances. In our scope, we have a boiler, CHP, gas heat pumps, but also cooking and catering equipments, fires, or some other types of heat generators. So the core of the project is really to look into the impact of natural gas with hydrogen on these appliances, but we also have 2 next steps, which are the work on standardization and certification. Chris will talk about that a bit later. And finally, we have a last step about mitigation. It is about how to help the appliance to cope potentially with a higher rate of hydrogen. It will be more clearer on the next slide, please, Alexandra. As you can see on that slide, the project is organized in 6 work packages. 2 work packages about organization and communication. So the work package 1 is led by NG. It's about the relationship with the FCH JU and the European Commission and the management of the project as a whole. Work package 6 is led by GURG, is about communication, dissemination, exploitation. So it's about how to make sure that the knowledge we are creating is shared with the stakeholders. So for example, all of you that are invited today, but also the general public, and that the most data is available for the wider public. One important aspect of the THyGA project is that I think 80% of our deliverables are public, so will be available for download on the website. We are really there to help the stakeholders to get a better understanding on what may be coming in the next years. Work package 2 is over. It was done in 2020. It's about the status of gas utilization technologies. So what is the state of the knowledge today in literature, from past experimentations, from the past tests in laboratories? How can we use that to create a test program and focus and prioritize some tests of some appliances? The core of the test will be done in the work package 3, experimental work. Then the work package 4 is about standardization and certification. And finally, the work package 5 is about some recommendation for mitigation measures. An important point is that we are not alone in the project. I mean, the basis of the philosophy of the project is to discuss with the external stakeholders. So we have a very strong advisory panel group. I think that most of you are part of that group. It gathers associations, research centers, but also many manufacturers or associations representing the core of the manufacturers in Europe. We also have some technical committees contacted in the scope of that advisory panel group. So that's a win-win combination. The idea for us is to get knowledge and recommendation from the advisory panel group. And on the contrary, these members will get first-hand access to what we are creating and can also challenge our results and make sure that what we are doing helps the stakeholders, helps the industry. And finally, I have one last slide, please, Alexandra. Okay, I just wanted to, on that slide, to summarize what is the core of each work package, and also to show you the repartition of budget, which more or less emphasize the weight of each of the work package and the core of what we are doing in the 2 years that we still have to do. So the work package 2, the goal really was to screen and segment the types of appliances on the European market. So we are talking, for example, of a general type for example, boiler that has some subcategories. We will have condensing boilers, we have open fluid boilers. Some we have some different types of control, pneumatic valves, and so on. So we want to create some segments and see the impact of blends on each of these one as finally as we can, but we will have to make some, we will not be able to test everything. So the idea is to make some general segments and then try to explore what is possible inside all of them. An important point for that is that all the deliverables of the work package 2 are published on the website. You will find the link there and I will send it to you in the conversation later. Work package 3 is really the core of the project. It weighs for more than 50% of the total budget. So it means really that's the focus of THyGA mainly. I don't want to put the focus there, but it's really the core. We have to test up to 100 residential and commercial gas appliances there through a generic protocol, of course, that will be adapted according to the type of appliance. The grant agreement, the contract we have with the European Commission states that we have to test appliances up to 60%. Of course, this is a maximum. The idea there is also to be in line with what happens on the field and what will happen. So I think we all have this global idea that we will not see more than 20–30% of hydrogen blended in a natural gas infrastructure. So the core of the test will be done below 30%. But I think Jean Schweitzer, which is in charge of that work package, will discuss that a bit more in the next presentation. The work package 4 is about standardization and certification protocol. Our goal there really is to support and make recommendation to the technical committees. We are not there to create something new. It's only 12% of the budget. We cannot do everything from zero. We really are there to provide useful work for all of you there to make sure that we want to help. Okay, so we will not create things that are not in line with what you plan or what you want to do. And that's really the objective of today's meeting also, is to understand clearly what are the different options followed by the technical committees or notified body or international experts on the topic, and make sure that what we are doing is in line with these recommendations. So you must really see the work package 4 as a support for your actual work, a way to go faster maybe in some topics or to help you on with some tests. Finally, the work package 5 is about recommendation for mitigation measures. So we want to see if it's possible to increase the acceptable rate of hydrogen for one type of appliance by, for example, adding sensor, playing on the controls, or some things, some technical possibilities. Of course, the advisory panel will be really there to challenge us in all of the steps of the project. And that's all for me. Thank you very much.
Okay, thank you, Patrick. Then I think we can go right away to Jean Schweitzer, who will present the work package 3. Please, Jean.
Oh, thank you, Chris, and good afternoon, everybody. So package 3 is about the testing, and as mentioned by Patrick, it's aiming to answer to the question what happened on appliance in real situation if we inject hydrogen. Alexandra, can you go to the next one, please? So so we have 3 kind of tests in the package 3. We have what we call short-term tests, which is the main let's say the main type of test we are going we are carrying out. So it's about testing appliances according a given protocol to check as far as possible within like a few days or 1 or 2 weeks, something like that. The influence of various parameters like safety, on emission and efficiency. The second kind of test are what we call long-term test. It's of course, as the name says, it's about checking whether there are some long-term effects of hydrogen on the appliance components. So we will have appliance for testing for quite a long time. As I think it's about 30 weeks. Where we are going to test according a certain pattern of use. This is of course limited to a few appliances because it's extremely costly. So we are going to test 7 appliances under this program. The first test will cover, as said already by Patrick, about 100 appliances. And the third test is about leakage, and this is also the one that has been mentioned, which THyGA is in charge of. So we are looking here at leakage from appliance and also leakage from the installation between the meter and the appliance. So we're not looking to the big pipes with the high pressure. So the philosophy, as said, is to look at what will happen in the real situations. That means that we are, in a way, simulating an installation where hydrogen is injected into natural gas. And we will go up to 60% because this is something that we have agreed with in the contract. But we will focus, of course, on lower percentage because let's say what we will face in the next decade is probably 20 or 30% and not more. So we are putting more effort in what is expected to happen in the future and not to what too extreme. But still, we are going to go over just to check some limits. So we don't change anything on the appliance. We just do the, let's say, when we don't take any, let's say, we don't change, let's say, adapt the appliance to burn hydrogen. It is appliances that are designed for burning natural gas. Unless there are some few that we were going to test that are designed with hydrogen as well. So new appliances, but the very bulk number of appliances we're going to test are just natural gas appliances. So we are just simulating what's happened there. So they are adjusted for natural gas, and then we inject up to 60%. And this is also we also testing a situation where the hydrogen percentage is varying between 0 and a given value. So maybe Alexandra, you can go to the next slide. So the gases we are going to use, we have defined the gases we are going to use, or the natural gas we are going to use, based on the work that has been done in the frame of the European gas harmonization. And we have there a report from the GRC and ENTSOG that has been made some statistics about the gas distributed in Europe. And we are taking let's say the 2 extremes that are distributed in Europe. Of course, might have been changed a bit in between, but this was the situation in 2019. And these are the values of the WOB index that are indicated in red on the slide here. So two other two gases that we will use as extreme for designer or test gas. Alexander, can you go to the next one? So here, maybe it's a bit small, but you might be looking at the upper line, which is what we call EU high, which is the highest Wob index. And if you look at the point on the right side at the top, that's a gas which is without hydrogen. And then in putting 10%, 30%, and 60% hydrogen will change the Wob index and the density according to the points that are on the curve there. So you have the density as the x-axis and Wob index on the other axis. And similarly, you have the green curve on at the bottom here. You have EU low, so which is a mix here, a theoretical mix between of methane and nitrogen, where the other one was methane and if I remember well, CH3H8. That's written on the curve here. So we have this is also the theoretical, let's say, composition of the EU high. And similarly to EU high, we inject hydrogen with starting with 0%. So this is the first point on the left, on the right side at the top, and injecting 10%, 20%, and 60% will lead to the density and Wob index that you can see on the line there. In top of that, we are also using methane, depending on the situation. So the kind of gas we are going to use for the testing will depend on the type of testing as well. So maybe you can go to the next one, Alexandra. Thank you. So this is basically the extended test program. So we are, as mentioned before, testing safety, performances, so emission and efficiency. And this basically that's the three, let's say, main area we are investigating. So without going into the detail, we have a number of tests which are also designed according to the appliance, because for some appliance we can combine safety test and efficiency test and emission test. For some other, you have to separate the test because of the procedure for testing from the standard is different. But as much as possible, we have tried to let's say to make a program that is bringing the best value for the money. So we are also testing, of course, we are testing to the, let's say, safety situation in different conditions that are mentioned on this list here. We have a cold start, we have a hot start, which is not a problem for the moment. It's at least. We have also extreme condition with lower temperature for some tests, and also we're testing with different flue gas lengths and so on. We're also testing the rate of change. So this is a plug flow with hydrogen injected suddenly in the appliance. We're also checking whether the flame detection is not impacted by hydrogen. And I see Chris, that means that I probably don't only have 2 minutes left. Is that correct? Okay. And one of the important things is that we are testing adjustment. I will go now on the next slide then. Okay. Flashback is one of the things that is, of course, expecting to happen when you inject hydrogen in the natural gas. And this is something where we have to harmonize the way we assess flashback. And it's not always easy. So we have a lot of discussion about that. But we don't have time to look at the details. So I will go on the next slide. Also, I like to say that with hydrogen, we expect that the flame speed will change, and the flame speed will change, or let's change differently depending if it's a atmospheric burner or a premix burner. And without going into the detail of this curve, we have used some simple model to calculate flame speed. So to design the testing program according to the the highest difficulty for the appliance, so to be certain to let's say to have the situation where appliance will have some difficulties with hydrogen. But this will be different if depending on the burner type, and this is something that is we take into account in the testing program. Maybe the next slide. So one of the important point that is also was important in a previous project called GasQual that some of you know, is that the adjustment is giving some additional difficulty for the appliance and can possibly also bring some safety issue. So we are testing appliances with different scenarios of adjustment. So knowing that the appliance is air ratio is fixed with instruction of the manufacturer for on O2 or CO2, depending on the manufacturer instruction, and then it is used with another gas, and this is somewhere you might have some difficulties. And we have tested here. We have on the program 4 different scenarios where we adjust with and without hydrogen at low level of Wobendex and high level of Wobendex, and then go to the other side. Once it is adjusted, we use the extreme other gases. And the last slide, maybe we'll have maybe just 1 minute to just give you some example of results we have obtained so far. The first example is about a boiler. So this is where we have an adjustment, what we call G here for the test. So it is adjusted. It's one of the most difficult adjustments because it is adjusted at EU low, so the lower Wobendex, where we have a scenario where we have 20% hydrogen. And then when it is adjusted, we change the gas without touching anything on the appliance, and we go to EU high, and then we inject hydrogen. So the curve on the left side here is showing you in orange the CO value obtained the first test after adjustment. You can see the CO is low, and then when you go to EU high, there is a strong increase of the CO. And then it is reduced by the addition of hydrogen. And this is for Qmax, sorry, and on the other side it's for Qmax, for Qmin, where obviously there is no problem. Another learning we had before I finish is that the flashback also may occur after a long operation of time. And this was seen on a cooker hob, for example, where there was no flashback for 2 days, and then when we did the test for efficiency, which is quite longer, then we had the flashback after one hour. And this is something that we have to, resulting from that, we have, of course, to change a bit the way we had to designing the testing. And I think this is maybe the last slide, if I remember well. Alexandra, maybe you can try next one to see if, okay, this additional slide, I don't think we should go on that.
Okay, thank you very much, Jean. I think that were some long 2 minutes, but I think it was worth it. So no problem at all. And I will speed up for what my presentation now is concerned. So because it is linked, it's a topic we are looking at today, but many of the questions will be addressed in further presentations or part of the questions I raise. So maybe next slide, Alexandra. Yeah, so the work package 4, what is it about? Well, the main goal is to evaluate the current certification and standardization framework for residential and commercial appliances, to recommend on a test program and test programs conditions, respecting the existing approach. It's not up to us to change. We need to change any current approach as long as there is no reason to do so due to the presence now of hydrogen. So there are a number of deliverables that are linked to this work package 4, of which one is ready and is on the public website. So the first one. So and the other ones will be finished, the 2 and 3 this year and 4 next year. Okay, next slide, please. So some considerations regarding the gas appliances regulation and other applicable legislation. As far as the gas appliances regulation is concerned, well, H2 natural gas is in the scope of the gas appliances regulation. It may compromise, however, existing appliances conformity to essential requirements. And maybe even new ones, because the current concentrations that are included in the member states communications regarding the gases distributed on their territories, they are quite limited, as you can see on the right. So it would be important, we think, well, for existing appliances, those that are already on the market, it also probably cannot be considered as what is called in the gas appliances regulation normal use. So probably manufacturer would not be liable for the product anymore. Appropriate H2 concentration is well, to introduce it as soon as possible is also very important, taking into account that appliances are generally there for a long time. And then obviously, besides the GAR, other legislation like eco-design, etc., may also be important. Yeah, next slide, please. So yeah, the current, yeah, there, sorry, you will have to push the button several times, but maybe, yeah, wait a little bit there, thanks. So you have, yeah, the appliance, the use of the appliance, and with working conditions, the conditions it will have to work with. And then you have the appliance certifications where you want to create test conditions reflecting those working conditions. Yes, please, Alexandra. So yeah, okay, then you can see that in the different member states, different criteria specifications do apply, like for here, for instance, for the WOBI index in the different member states. Yes, please. So that is the distributed gas, so what appliances need to cope with in the test conditions, that'll be reflected in, on the one hand, test gases that are defined in a standard European standard EN 437. And in together with tests and requirements for specific for each type of application in the different written down in the different appliance standards. So and then you have, yeah, for natural gas, yeah, please go on, push sometimes, yeah, a few times the button. Yeah, thank you. So natural gas, for natural gas distributed, you have for as far as the definitions in EN 437 is concerned, it belongs to the second gas family. There are different gas groups, and we are looking specifically to the H gas group here. And there is a reference gas and limit gases that go along with that. Yes, please. Yeah, so besides that, there are other gases also that may be distributed, still like LPG, a little bit less town gas, but those are the other families of gases. And then on the right side, yes, please, on the, yeah, you have the different type of requirements that are described in the appliance standards. Okay, next slide, please. So some considerations regarding the test gases, they are defined as set in EN 437. The gas family, the definition of gas family as it is today in the standard is saying it's a group of gaseous fuels with similar burning behavior linked together by a range of WOBI indices. But okay, similar burning behavior, you could question that maybe as hydrogen is significantly different from methane, the main component of natural gas. And looking to the range of WOBI indices, adding hydrogen concentrations in higher concentrations, you could end up with WOBI indices lower than the lower limit of the current second family. And then you have a number of gases that are in the table below, as they are defined in the current EN 437 standard. So with a reference gas, and there the question is also, okay, is one reference gas still the right thing to do, as it is used for most of the tests afterwards on performance, etc. And then you have the different limit gases looking at one specific risk generally. So, and there also there are questions, of course, whether you would need to change those. Like, for instance, the one on light back, it needs to be adapted, obviously, to the hydrogen concentration we may look at, and maybe also taking into account a worst perspective. I wouldn't call it the worst perspective, because the worst perspective is if you look to, for instance, a maximum of we often talk about 20%, 30%, but is that what the appliance will be supplied with all the time? Maybe it will change. It could vary over time, and maybe it will go beyond the maximum value sometimes. The worst perspective would be 100% of hydrogen if you end up on concentrations like this, but of course I think that is not what the intention. Okay, maybe yeah, and also eventually any new limit gases that would be needed for new risks to cover new risks. Okay, next slide, please. Yeah, and then so there's the last one. So the considerations regarding tests and requirements. As said, you have a lot of product standards, also product standards covering different types of gas appliances, central heating, boilers, water heaters, etc. But many. And a lot, but they contain a lot of similar tests. They are describing a lot of similar tests, but adapted specifically to the concerned type. But one needs to ask oneself if the existing test conditions and requirements are also adapted to the presence of hydrogen. So, and then, for instance, we are looking like things that also have been mentioned, like gas leakage, maybe inside the appliance, unburned gas accumulation inside the appliance, and mechanical resistance to delayed ignition, integrity of materials, and also the not to be forgotten, very important, is the proper functioning of control and maybe even more of safety devices. So, okay, I think that's it. It's quite fast, but I think many of those questions are also addressed in the further presentations. So, okay, that's the end of the first block. We'll right away continue with the second block, and then afterwards we take some time for questions on the presentations we had. So the next one is the presentation from Gertj. I think Robert, you start, or Jean?
Yes, thanks, Chris. I will start. I will spend a minute or two just introducing the project and then hand over to John. Alexander, if you can move on to the next slide, please. Just as a summary of this project, I know several of you in the meeting are already fully aware of what we're doing, and some of you are even involved in this project. But over a year ago now, actually, in 2019, we were approached by DG Energy on the basis that we'd already done some work within Gertj on biomethane on behalf of CEN TC408, looking at barriers to the introduction of biomethane. And then they were very keen that we established a similar sort of priority list of issues for hydrogen, and we worked then closely with CEN TC234 in particular, and Hiltrud Schulken, who I know is on the call today, to work to prioritise a list of topics and areas which were seen as significant barriers to the introduction of hydrogen into natural gas networks. And that led to a significant and extensive consultation process where we worked alongside or brought in knowledge and views from a number of CEN technical committees, from sectoral energy management, sectoral gas infrastructure, gas utilisation. We cast the net very widely to determine what the priorities should be. Initially, we were asked to look at 4 or bring together 4, and then that was extended to a list of 8. We had about 14 or 15 on the list, and some of them were combined to give us this list of 8. But the list of priorities that we're looking at with regard to the introduction of hydrogen really, to some extent or a large extent, conform to the kind of height of the barrier that you might see in terms of introducing hydrogen. For example, the percentage, if you're looking at blending, safety and gas quality, of course, are very much transversal and cross-cutting, and we need to explore the issues around safety, gas quality. Underground storage, of course, there is a significant potential barrier in terms of the unknowns with regard to percentage of hydrogen that you can introduce. I mean, we're not talking here about necessarily 100% hydrogen, but when you start introducing hydrogen blends into natural gas, there are barriers. Power generation, industry, steel pipes, network equipment, end use. These are all areas where there are unknowns, and we need to do a gap analysis to determine what the next step of pre-normative requirements are. The intention behind this project being that once we've established what the gaps are, what the knowledge gaps are from existing knowledge and literature, we can then move on to define a pre-normative research program. This is being, as I said, supervised and led through a working group within TC 234, which is chaired by Hiltrud, and we had a big supervisory board meeting on that yesterday. So effectively, we're bringing in the expertise from the whole of GERJ, about 100 plus members of GERJ across about 20 different companies, plus the combined expertise of that supervisory board, which has stakeholders from across the industry and beyond, including, for example, associations which are brought in from areas such as the chemical industry, other industry sectors, which of course will be impacted by the introduction of hydrogen, as well as the kind of gas network operators and infrastructure operators, and end users that we will be concerned with in terms of the introduction of hydrogen. In terms of today's meeting, of course, the work package 8 is the important one, or links most closely to the work in THyGA. We can move on to the next slide, Alexander. Let's just go over these. And the timescale really is to complete this work this year. We're still at the first stage of assessment. We had, as I say, a major meeting yesterday, which kind of brings us to the end of the first phase of, well, not the end, but virtually the end of the first stage of knowledge gathering. We're now moving into the stage of assessing the gaps in the knowledge, and ultimately we'll be looking to do recommendations for future pre-normative research. Which we would expect would lead then into a number of research programs, which will lead to an improvement in the roadmap to standardization. Because importantly, of course, pre-normative research is about standardization. It's about certification to some extent, but standardization is the basis of this work. And as I say, it's moving very fast, and we are catching up in that the contracts were signed quite late by the Commission and sent compared to the actual timescales, but we're moving very quickly, and we expect to come up with the first assessments within 2 to 3 months. So having introduced it, hopefully in only about 2 minutes, I will hand back to John, who will tell you about Work Package 8.
Thank you very much. I think there is some echo. Maybe somebody has a mic. Okay, so for priority 8 of the project is end-use equipment, as mentioned already by Robert. So we are looking here at the sensitivity of end use on when using hydrogen. So our WP4 is more or less dedicated to commercial and domestic and commercial appliances, while industrial application are, as you understood, also treated as well as power generation, but in other packages. So what we like to do here is to establish first a kind of picture of where we are, what kind of level of hydrogen can be accepted by the different application, and from that also look at what are the need for pre-normative research in order we can move on. We are of course looking at the issue as one we are looking at in THyGA. We are looking at safety, but also at emission and proper use of appliances and emission. So this is playing very well with THyGA, and there is a lot of synergy with THyGA, and there will still be a lot of synergy with THyGA in the weeks and months to come. Maybe I will go on the next slide, not to use too much time. So what are the activity are at the moment? So you have to know it's not a big project. So we have quite, let's say, restricted funds to do the work. So we are not going we cannot. We have to let's say to stick to what we have in the literature and what we know, the expertise we have around the table. We have no room for testing, no room for whatever fancy investigation. So what we are doing at the moment, we have gathered that was done by our Robert, Alexandra, and Georg team, collect let's say something like several hundred. I think it's 900 references at the moment that are dealing with hydrogen. And at the moment, we have identified like something like 240 of tools that are relevant for the VP8 for the end use. And we are not going now. We are now going to work onto the reference and to take the information that we need to for the project. So maybe next slide again, Alexandra. So we are, maybe that's not very interesting, but just to say that we are a few laboratories there. We are 6 laboratories or 6 partners that are doing the work, and we have some let's say distributed the work among the experts. We have when we know they have a strong, they were strong on some areas, they were given, let's say, to work on 2 specific points. And we have, as I mentioned, there is a lot of, I will not say overlap, but there are some common topics between the different priorities. And there is also an important element as it's to connect to the other groups that are working on, for example, safety or gas quality, which are things that are very relevant for us as well. Maybe I will just go out on the next slide. So what we are going to do here is that we at the moment, so we are gathering the expertise. We are let's say starting to analyze of the different references, and we will use a matrix, and I will show you to work and as a tool for putting the information together and analyzing it. So maybe I will go directly to the next, and this is explaining the matrix. So we have in this matrix we have on the left side you have the let's say the segment. We have about 60 segments which are different type of application, and this is a direct outcome of the THyGA project. And on the horizontal we have the columns where we have different aspects to look at, and I will give you a few details about that. And maybe I will just go to the next slide. I can just feel I don't have very much time. So we have in the different columns, we are looking especially at the impact of hydrogen on the safety. So we are looking at all the points that are on the table here, from flame detection system, flame stability, and so on. And we are also looking at the overall performances for the service for which the appliance is designed for. Like, for example, the heating time for cookers, which is an important parameter, but we're also looking at environmental impact from emission to noise and so on. And let's go to the last slide. Just okay, now no, sorry, just back on the last slide. Those are so far the appliance standard that are concerned by our VP8, and we have identified yesterday a few more, so the list will be updated. And I want to use a bit of time on the last one, on the last slide here. So this is what we are going to do next steps. So when we have done the analysis with the method of the matrix that has been described shortly here, we are trying to identify what are the learning about sensitivity to hydrogen for the different segments, and also what are the possible learning about R&D needs for in terms of prenormative research. And then we would like to make the analysis, and we like to make some brainstorming with what we call the industry. So it will be basically manufacturer, experts, and TC members. So we are, if you are interested to contribute on that, we will be very glad to hear from that. But Hiltrud is in a way also let's say gathering the interest from the scene toward a big table where the different interests of interested people are mentioned, but if there are some maybe people outside the SEN group that are willing to help there, we are very interested as well. So thank you for your attention, and sorry again to maybe have taken maybe too much time maybe again.
No problem. Thank you, Robert and Jean. Okay, now we move to the different SEN initiatives or the ongoing work in the different SEN different SEN TCs. And the first one is SEN TC238 with Noureddin Mostefaoui. Noureddin,
okay.
Please.
Thank you, Chris. Good afternoon, everybody. I'm going to make a short view about EN 437, which was published by TC238 and which I'm sharing. So this standard was first published in 1994 to respond to the gas appliance directive in that time, which was 9396 EEC. Then it was amended many times between this date and 2009. And then we revised again this standard, and it was published in 2009. Here, according to the new directive, which replaced 9396, which is 2009-142 EC. And the last version, which is published, it was in 2019, which is again revised, and it is under process for publication. And the main, go to the next slide, please. This standard defines the test gases which are used to test for the certification of gas appliances, all gas appliances except those not covered by the gas appliance directive. Now it is the gas appliance regulation. The test pressures which are used also for the testing for depending on the categories of the appliances. And it covers also not only natural gases like H, L, or E groups, it also covers LPGs and manufactured gases. And as you know, for the standard, we already have manufactured gases, or also called synthetic gases, which contain a lot of hydrogen. And as you see, we can go up to 59% of hydrogen in the gas for G112. And these gases was already used in the first version of the standard, mainly in Scandinavian countries like Denmark, Sweden, and also in Italy and Germany. Go to the next, please. To show you, maybe Jean talked about this, but I'm going to talk in another way. This is the representation of the natural gases, H, L, and E. So in blue squares, we have natural gas E, which is having a reference gas G20, 100% methane. And then to make the extreme gas for incomplete combustion and soothing, we have to add propane, which is on the black right side on the picture. And to check the flashback, we have to add hydrogen to increase the speed or the combustion flame. And here we have 20%, 23% of hydrogen, which is added to methane. And the gas is called G222 in the standard. And to check the lift gas, the lift of the flame, we have to add nitrogen to reduce the flame speed. And the gas is G23. Also, sorry, this is for category H. The gas is G231, and G23 is used for gas H. And as we see, the same gases are used when we have the category E, which is covering also category H. And the red triangles are the gases used for L gas, which are G25, the reference gas, and the two limit gases are G27 and G26. Can you go next, please? This is maybe Chris already talked about. So the gases which are used for group H, maybe we just saw about G20, G21, G222, G23. And also we have another gas, G24, which is called the overheating limit gas, which is used by manufacturers and not for certification to check the impact of the high heat or the fluctuation of the heat on the burner. We add propane to increase the heat and also hydrogen to increase the flame speed. So the flame is mostly stabilized on the burner surface. Okay, next. This is already showed before, but just to insist that for manufactured gases, nitrogen is added to reduce the flame speed and also to reduce the flashback. Otherwise, if we don't have hydrogen, only methane and hydrogen, the flame speed will be very high, and then we have a large influence on the flashback. Next. Okay, what is the impact of hydrogen? As Jean said, and also Chris, the main problem is the flashback, because when we add hydrogen to the gas, we are going to increase the flame speed as shown on the diagram, the presentation of the flame speed as function of hydrogen content in the gas from 0 to 50%, and for different excess airs or lambda. Okay, lambda is 1 plus excess air over 100. So for 20% excess air, we have 1.2 for lambda. And as Chris also said, the impact of the hydrogen is the flame stability, the flashback, because the flame speed will increase relatively compared to the gas without hydrogen. And you have also an impact on the performances and the emissions depending on the quantity of hydrogen added to the gas. Next. So the impact of hydrogen is pushing most of the CEN-TCs to relook at the standards to see what is the impact of hydrogen on the performances and the emissions and adapt the standards accordingly. So in TC238, we have EN437, which is actually under revision, and the inquiry was passed without big technical comments. So the TC decided to publish it without formal vote, and maybe it will be published this year, the beginning of this semester. And the TC took a decision in the last plenary in last September to revise the standard in 2 steps. The first step is to integrate in the standard mixtures of natural gas and hydrogen up to 20%. And this will be started as soon as the standard under publication will be published officially, maybe in the beginning of next semester. And as soon as the revision with hydrogen is finished, the version which will be published, I call it version 21 because we are going to start the work this year. Maybe it will be published in 2002 or 2022 or 23. We launch the revision for hydrogen to revise the standard. And the details of the work which is done in parallel with CEN-TC 109 will be presented, I think, by Michel and Mindert. I think it's the last one, and I thank you.
Okay, thank you very much, Noureddin. You also respected time very well. Thank you for that. Now we are moving to Michel Oldenhoff, who is chairing a working group or ad hoc group from the CEN-TC 109 on central heating boilers. So please, Michel.
Yes, thanks for the invitation to this workshop. My name is Michel Oldenhoff. I'm working for Bosch Thermal Technology in Deventer, in the Netherlands. I'm also expert in the TC 109 Working Group 1 and Working Group 4 for several years. In September 2019, I attended the TC58 workshop for hydrogen on behalf of TC 109. And basically, that workshop inspired me to do a proposal within TC 109 to raise an ad hoc group. And the proposal was containing basically 3 job tickets. They are already on the screen. The first job ticket is to look what existing appliances can handle. The second one is creating a new gas category for appliances up to 20% of hydrogen. And the third one was for appliances with 100% hydrogen. Basically, those three job tickets we had, and then looking into the EN 15502, what needs to be changed in terms of tests and what we need to do about the limit gases. At the start of this ad hoc group in February 2020, we identified that also the THyGA project was started, basically looking also at testing the existing appliances. So we immediately took a decision only to focus on job ticket 2 and 3, by the job ticket 1 was taken care of by the THyGA project. In this ad hoc group, we also, sorry, next slide, please. I'm going too quick. So as always, when you do a proposal within a TC, you get the task. So in my case was the same. So I was appointed as a convener of this ad hoc group. I'm also secretary, and Dennis Klein is taking the notes in the meetings. We have in total 18 people in this ad hoc group, people from the Netherlands, UK, Germany, France, Italy, and Portugal. Also in this meeting, there are 7 members in of this ad hoc group today. We had in total 5 meetings. We started February last year, and our next meeting, you can please press the button. See the overview of the meetings we had. Last meeting we had in February, the next will be in May, and next to the focus on the job tickets, we also invite people for presentations. Also, Stefan Carpentier is giving frequently an update of the THyGA project. We get an update from the UK on the high deploy, the high for heat, and also from Germany on the H220 project. So we really want to look also around us what is happening and make sure that we go in the right direction. Next slide, please. So achievement after 5 meetings. Job ticket 2 is now nearly finished. We have written a draft amendment for the EN 15502-2-1 for hydrogen natural gas appliances. We will have the final review of this in May. Then we have our next meeting, and then the goal is to hand it over to TC109 Working Group 1 for creating a new work item. And I hope that can start during the second half of this year, this new work item. The second one is, and Noordin already talked about it, is the proposal for the marking and the limit gases. That is also included in this amendment, and we hope to finish that one also in the next meeting. Yes, in the job ticket 3, that is to be started also in the next meeting. Hope we have time for that, otherwise it will be shifted. But we will look then also if that job ticket will be written also as an amendment to the EN 15502-2-1 or as a separate part. We already identified by going through the standard that for 100% hydrogen, we definitely need to adapt more in the standard than just 20% blend. Okay, and then the next slide is, I think, the most interesting one. This was mainly about the process. This slide is showing the adaptations we have done. The first one is about the marking of the hydrogen natural gas appliance. The gas category we could mark with a Y, and following by the number to indicate the amount of hydrogen in the gas. For example, the 2EY20 to indicate the 2E category with 20% of hydrogen, and with 20% hydrogen volume in the gas. Next point. The amendment is written for a maximum of 20% hydrogen volume in the distribution gas, which means a range of 0 to 20% hydrogen is covered, and especially this range is important because we're not talking about just 20% of hydrogen, but the range of 0 to 20%. Next point, yeah, the nominal heat input. We still take the reference gas. So if you have the 2EY20 gas category, we take the G20 as the appliance with, as the reference gas for the heat input, and then we use the plus minus 5% and 500 watt heat input tolerance as we have today. And next to that we have a second gas that's then the 2EY20. That's the next point, and that's basically the reduced heat input gas. but there we don't put this tolerance on, but it's just a declaration from the manufacturer how much heat input you have when 20% of hydrogen is added to the gas, to make it clear for the installer and customer. Next point, it is also obligatory from the GAR. You have to do a risk assessment as a manufacturer, and of course you have to extend this one for the materials used in contact with hydrogen. So that's one of the additions. The late ignition topic needs to be done both with natural gas and the hydrogen blend. Next point, the combustion measurements and calculations shall be done on O2 instead of CO2. That's also a change that we have done. And the light back needs to be done with a higher % of hydrogen in the test gas. We come to that on the next page. And I think most of the important things is, and it is already mentioned in the earlier presentations, is the adjustment or maladjustment of the boiler. Because you can just adjust the boiler at 20% of hydrogen or at 0, and that makes some difference. It was already explained in previous presentations, so I will not go further in detail in that, as we have limited time, I understood. Next one is about the limit gases. There I have to make clearly a statement that is still a proposal. It's not finalized, but basically we have two proposals here. One we call the classic proposal, and it's in line with the current EN 437. But instead for the light back gas, where we normally have G222, we use the test gas G22. It has 35% of hydrogen. So we have the normal gas category, you have 2E. The reference gas is G20, and when you go then to T2EY20, basically all the gases remain the same except for the light back gas. There you have this higher amount of hydrogen. And then we have the alternative. The alternative is basically in line with the proposal in the PAS 4444 in the UK for 100% of hydrogen appliances. There they propose to use a lambda variation of plus minus 10%, and that plus minus 10% lambda variation we can also use with 20% of hydrogen, or if you have a higher blend for 30% or 40% in the future, this approach can be used as well. But it's still a proposal, and it's also still under discussion within our own ad hoc group. So there I have to clearly make this statement. It is a proposal, and it of course is still pre-normative work here. So I think this was the last slide.
Okay, thank you, Michel. That was clear, and I think there a lot of work has been done there too. So it's interesting, and probably it goes indeed fast to understand or to follow everything for people that are not directly involved, I guess. But okay, unfortunately, we do not have the time to discuss it in detail. Okay, thank you very much. We will go to the last CEN presentation. So that's on CEN TC 58, and that is Mr. Martin Bergerman chairing this TCA. Martin, please.
Yes, hello. My name is Martin Bergerman. I work with Siemens in Germany. We produce controls. And I'm also chairman of AFICOR, the European Controls Manufacturers Association. I'm a member of TC58, but not chairing it. But we have taken an approach to do a pre-normative work for TC58 because the standardization process might be slow. Will take 3 years maybe, and we are under pressure since a lot of pilot projects have created a demand for let's say, controls to be used with hydrogen. For the gas carrying products, a hydrogen blend is not so much of a problem. It's more a subject of combustion processes. So we are focusing actually on use of 100% hydrogen, which poses different challenges. Some of the topics are listed on this sheet. I will not go into details here. I will more explain how we work and how we want to get to results. So we are aiming at fast standardization processes. Next slide, please. We started already in 2019, where we kind of brought the experts together to discuss the topic and how to approach it. And that was just a kickoff. The follow-up meeting then in 2020 was cancelled. We had COVID issues with all kinds of meetings, as we all know. But then in October, we resumed and we identified the topics we need to address. And we divided them into 4 different groups that we established at that point to deal with the individual topics in these groups and work simultaneously to speed up the process. We had then already a meeting to discuss the first results in January this year. And as you see from the timeline, we have now a good sequence of project group meetings. And our goal is to write a CEN-TR within a year that can be used by as a guideline for the TC58 standards and maybe for others. Next slide, please. Group 1 deals with leakage rate and breather holes. This becomes a topic if you go to 100% hydrogen. We looked at the lower explosion limit as the safety parameter to deal with, and we also looked at the minimum air exchange rate requirements, because if you have a permitted leakage inside a building, you also need to see that the concentration cannot build up. This is in relation to discuss safety. We have done tests by several manufacturers to check the leakage with pure hydrogen and other gases to compare, and amazingly we found there is no all too significant difference. This indicates that we have for internal and external leakages, we have more a laminar flow model, and that indicates that the limits that we have in our standards today might be okay. There's also insignificant temperature dependence. Where we have a subject that is more asking for attention is breather holes. So if we really assume a diaphragm failure, then the breather holes deliver higher rates of flow, which are significant and need to be addressed. Since here we don't have the laminar flow, here we have turbulent flow, and then with the breather hole diameter, the flow increases quickly, and here we need a risk assessment. This will not go without changing requirements. Next slide, please. The group 2 deals more with combustion safety, and this is actually some cooperation with TC131 forced draft burners. They work on the topic of accumulation of leakage rates. If you have several components in your installation that deliver permissible leakage rates, then you have to look how does it build up if you have many of them. Of course, you have the flashback subject purging procedure. You have to look at products where you have sometimes air inside and sometimes hydrogen. What does it do? Do you get some dangerous mixture in those components, and what do you have to think about that? Then what do you do if you have to replace certain parts and you have to open up your system, like filter exchange, valve exchange, actuator exchange? Another subject that is more on the combustion side is if you move towards 100% hydrogen, how do you detect incomplete combustion? Because there's no CO left. You have to find different methods to deal with that. And also there's certain factors compromising product lifetime if you have a higher heat exposure. Next slide, please. The third group deals with sensors and electronics. We have to look at the flame detection signal strength, and there might be topic in the adjustment of safety times of burner controls. The focus is on the relevant standards for burner controls, for the electronic fuel air ratio controls, and the combustion product sensors. The ionization sensor sees limitations when you move towards 100% hydrogen. So in this case, it has to be checked whether the method can still be used. Some impurities within hydrogen do still produce signals for a ionization sensor, but is this enough, and is this a reliable method? That has to be changed. If we move to other types of sensors, more the optical types, then we have to look at the spectral range of the signal of the flame and how it matches between natural gas and hydrogen. And here we also have encouraging results. For hydrogen, you need higher ignition energy, and that also may affect the timing of your flame safeguard devices. And of course, we have moisture becoming a factor to be considered, especially if you look at the sensors close to the flue gas exit. Next slide, please. The fourth group we have looks at materials under parameters like temperature and pressure. So far, we see that under the temperatures we use in our applications, the temperature does not seem to be a factor. And well, if it does, we would have to need the operating temperature in a certain classification scheme to be added to the standard. You can have high temperature, you can exclude them for temperatures below 178 degrees, but you may see some H2 embrittlement, and that's something we need to look into with more focus. And also springs might actually have to be investigated separately to see how they behave, because springs are typically a failure exclusion in our assessments. Next slide, please. So this is already my last slide. How does it go on? We have detailed discussions in the project group. The next one is tomorrow. There's a close sequence of events to really do the work in greater detail. At the moment, we have a draft EN 13611, which is our general safety standard, where already the parts that need to be addressed are marked up so that we can work through them step by step. We compile all the investigation results that we are getting in a document, which should be made available within a year, because if you work in the standard, it's longer, and we need this fast. So we have submitted a new work item proposal for a technical report, which should be this document that I mentioned. This proposal has been submitted to CEN/TC 58 for decision. The next plenary is already on April 9th, and we will then decide on that. And we may have to establish a new working group for that, for formal reasons for the way the CEN is working. And here's the name of the work item proposal. It's supposed to provide guidance. A technical report is only a guidance document. It is not a standard, but it should provide the input for the single working groups within TC 58, what to do with the individual standards. And for every result we have, we would like to give the reasoning, why we believe this is the result and why it has to be like that, not doing estimates or guessing, but always find good reasons that back up a certain recommendation. And that was it from my side. Thank you.
Okay, thank you, Martin. Also very interesting, and I think very important too, as of course your controls and devices and safety devices are used in the different products we know, not only in boilers but also in all of the other appliances and applications. So thank you very much. So now I think before the break, there is some room for some time for questions. I propose that if you have any, that you raise your hand and that you say to whom you want to address your question, and then formulate your question. Is there? Yeah, I can see that. Howard, please. Howard has a question.
Yeah, actually, I have. Hi, Chris.
Hi, Howard.
I have a question for Jean about the appliances being tested and whether these are new appliances or appliances taken from the field.
Thank you, Howard, and nice to see you again. Yeah, we have, in fact, taking appliance from the field is very difficult. So we like to have appliances that are taken from the field, and honestly, we are not going to people place and take appliances there. So we have a kind of mix of appliances that were in the labs that were already tested in different projects. So some of them have maybe a few years, have been few years in the lab. So they're not completely new, but they are not really used in normal situations. So, and the other appliances are new, say it's sent by the manufacturer. So we are in a way facing the same problem as we had at the time we were working together on gas qual. So it is unfortunately we cannot afford to take our appliance from existing installation.
If I can cut to the chase, the real reason for my question is that I thought I saw something in your experimental protocol that looked like readjusting appliances in a sense that would simulate effects of aging or maladjustment in the field. So whether there's a way to account for that, we all know what happens in the field, whether you could simulate that in a laboratory to a certain extent.
Yeah, we are just, in fact, we are just simulating an adjustment situation without knowing the gas that is, in the grid. That's what will happen, and then it changed. So, but it doesn't account for the aging of components or whatever can happen there. So,
yeah. Okay, thanks.
You're welcome.
Okay, thank you for your question, Howard. For your answers, Jean. Mark Krauter, you also seem to have a question. Mark, you have to unmute your microphone.
Sorry, embarrassing. Sorry. We will be taking, in about an hour, I'll be telling you about how we've taken the laboratory into the field. So yes, we've been doing that.
Okay. Thank you. That was it for your intervention. Yeah, thank you. Then Maurizio.
Yes, hello everybody. My question was for Martin, but also for the team. We are now selling products and components also for the town gas in some part of Europe or even in countries out of Europe. And about the sensitivity to nitrogen of materials and sensors, can we extend the knowledge and the information that we have for the town gas to a certain extent also to the mixture of natural gas and nitrogen?
I believe we can, because a lot of products that are on the market are still certified for gas family 1, and some of them were in the very past used together with town gas. And we don't have the topic that was mentioned earlier during the presentations that you have a problem with a flashback where they have to use nitrogen to balance that. For us, nitrogen or hydrogen are just gases that we carry in our products, and because of that, we see that a certain percentage of hydrogen has already been used in the past. And based on this experience with products that had been certified and used for a very long time, we can assume that admixtures up to 50% are okay for products that have a gas family 1 certification. Of course, some of the products, this was no longer relevant because town gas is a long time ago, at least in Europe, but it is still used in other places on the planet, and some have certified their products accordingly, and other ones are doing this subsequently now. So that at least for admixtures, you have a certificate. The problem is, how do you prove your product is okay for a certain application? You can work with manufacturers' declarations, but that is not satisfactory for a long time. We believe we need to make sure we use the standards that are there, if applicable, and that's good for town gas. And then if we move towards 100% hydrogen, we need to do additional work. But the work needs to go into the standards so that we have a clear document to which we can certify.
Okay, thank you.
Okay, thank you very much. Maybe some more questions. I see that Howard, your hand is still raised. Do you have another? No. Mauricio, neither. So if there are no more,
No,
then
I'll raise my hand again.
Sorry. Yeah, please, Howard.
Yeah, I have it's more of a remark. I don't remember who talked about the new test gases and talking about G22 versus a method based on PAS 4444. If I may, I'd like to make a remark on the PAS 4444 suggestion of using lambda times 0.9 as an alternative for a hydrogen-containing test gas. And I would like to argue that for lean premixed appliances, that may not be a bad idea, but for rich premixed appliances, that's the wrong way. So for anything of that's not fully premixed, that'll give you the wrong answer. So I guess you guys probably know about that, but since I saw it, I figured I'd respond to it.
May I respond to that one?
Yeah, sure. Please, Michel.
Yeah, the proposal I was explaining was for fully pre-mixed appliances. Maybe I had to make it more explicit, but it was for fully pre-mixed.
Yeah. Okay, that's better. Although, but just between us, I like G24 better, but that's fine. Okay, yeah. Fair enough. Thank you.
Okay.
All right. Thank you, Jörg. Leicher also has a question or a remark. Jörg, please.
I also have a comment on that idea of using a lambda change in order to not use another test gas. You have to be careful, I think, in this discussion. Of course, if you change from one gas to another, you have a lambda change, unless you have a controlled appliance. And if you have a controlled appliance, then all the changes do not occur anymore. So, for example, if we change from G20 to G20 with 20% hydrogen, and we have an uncontrolled appliance, then the air access ratio that the system is adjusted for goes up. So this has an impact on temperature. This also has an impact on the laminar combustion velocity. But so actually the laminar combustion velocity will go down, although we have a higher or will stay roughly the same, although we have hydrogen in the system all of a sudden. If, on the other hand, we have some kind of combustion control which enforces a constant lambda, then the laminar combustion velocity will go up significantly, because then we don't have the compensating effect of the access ratio change. So I'd be careful about that. Just switching or just adding a little bit of access, or reducing a little bit of access, because if you have a system with combustion control, this may lead to quite unsatisfactory results. Thank you.
Michel, please.
I can also respond to that remark. Within the TC 109, we also have now an ad hoc group, or basically a joint working group for gas adaptive appliances. And there we also have this 20% of hydrogen blend in. And there we use, instead of this plus minus 10% lambda variation, we use plus minus 5% lambda variation, but on top the tolerances of the lambda control of the appliance. So that's a different approach than the fully premix pneumatic appliances. So there we distinguish those two technologies in the EN 15502.
Okay, thank you. Howard, I think your hand stays raised, or you have.
I don't know how to turn it. Oh, lower hand. Sorry, my bad.
No problem. It's just to make sure that
I'm
you had another
retired.
question or not. No problem at all. Good to see you, by the way. No, I have a question more of a general question, but it's also to Michel. So the work on TC109. So if you're talking about the kind of other reference gas with 20% of hydrogen, is it also the idea of that it would be used? Because okay, if you look to the current reference gas, the reference gas is used to do plenty of testing regarding the performances, emissions, etc. of environmental nature. So is that also the idea, or what kind of tests would have to be done with the 20% of hydrogen reference gas?
In terms of emissions, we will still use the normal reference gas. So there's the G20 gas, so without any hydrogen in. But this, let's say, the declared heat input gas or the reduced heat input you have with 20% of hydrogen in the gas. There's just a declaration in the installation instruction. You can also, of course, show also the emissions to the installer, but further, there are no extra tests planned.
Yeah.
Okay.
Because the addition of 20% hydrogen to the gas impacts only the flashback. All the other parameters will go in the good side or good direction. The combustion is tending to be more clean than without hydrogen, and also the lift gas, the flame will be more stabilized than with the gas, because hydrogen will try with pushing the gas on the exit of the burner.
That actually depends on whether you have a control system or not, because if you have a control system and you add hydrogen, then you will probably start having higher NOx values, because you then have a higher combustion.
And that is
temperature.
relevant. Yeah, that's also why I'm asking, because okay, you see an increased. Okay, that's maybe because I'm a little bit biased, as here in Belgium, where we have requirements of measurements to be done on site, also on residential appliances. So and then if you look to, for instance, to NOx, okay, then if you make on-site measurements, then maybe the value just measured with G20 is maybe not the reference anymore.
I think
the fields could be very different.
The answer was given by Michel before, because for combustion controlled appliances, we have the same gases which are used for normal gas. But this is applicable only for uncontrolled combustion systems, where the excess air or lambda will increase when we add hydrogen.
Okay.
So the NOx emission have a tendency to decrease because we have more excess air, so the flame temperature may also decrease.
Okay, yeah, maybe we should not discuss it further in detail, because I think there are more. Jean, it's also related to this, I guess, that you raise your hand.
Yes, I have also a question for Michel. It's about, well, I have in fact two questions to him. The first, I understood that you're waiting the THyGA project results to go ahead with maybe some work on existing appliance. But what is the content of this work could be? That mean you're going to develop a testing protocol for checking appliance on site or something like that? That's the first question. And the second question is about, I understood as that you are considering a new flashback limit gas. Are you also working on a maybe more defined description of how to proceed this test? For example, we find out that the duration of the test is quite important, and would that kind of element will also be touched in the standard?
Okay, I'll first answer your first question. It was basically about the job descriptions. I explained at the beginning of my presentation. We had 3 job tickets. One is the first job ticket one. That's your question about is about what to do with the existing appliances. But yeah, the TC109 is dealing with the standard for appliances that are manufactured today and in future. And that's also one of the reasons we focus on the 20% and 100%. So we're not looking to the appliances that are already in the field. And as the THyGA project was started to focus really on what appliances already can do today without being certified for hydrogen blends, we decided to focus only from the ad hoc group only 20% and 100% hydrogen. So, and your second question, sorry, I know I have a bit lost.
It's about the flashback test. If you consider also to have a bit more detail about how to perform the test, especially the time that you need to wait for checking whether this is flashback or not.
Yeah, it's mainly about the duration of the test. As you found in the test within the THyGA, you already explained it in the presentation that you need sometimes more time than before really a flashback occurs. Yeah, maybe that's something a learning that could be taken into account into the standard, of course. If this is really seen in the lab now with the tests. Yeah, we all are building now up our knowledge here. So from that perspective, I think we should take it into account the duration of the test.
Okay, thank you very much.
Welcome.
Okay, thank you. We are close, but we are a little 10 minutes late, I would say. I have 2 more questions that could maybe be answered shortly, although I'm not sure. So that is okay. Why? Because why it's linked is TC238 and TC109 also with the choice. I think it's okay, understandable that you change from G222 to G22. So from 23% to 35% of hydrogen for the flashback limit gas. But okay, is it? I always struggle with the question, or I don't have an answer today, where the 20% exactly, or the 23% and the 35% exactly came from. I think originally, if you look to the numbering of the test gases with G20, G21. G22 probably with 35% hydrogen, and then G23 and G24. So now it's since many years or decades almost G222. But based on what is it? Because there was hardly any hydrogen in the gases that were distributed. So why is this? Why the choice for the 23% for gases without any hydrogen, and then now up to 35% for gas with up to 20%?
Mindert, I think you can answer that question the best. I think this is maybe about the history of the.
Yeah.
It's about history. People ask me, I don't know why.
Yeah.
Must be my age.
Sorry.
You're young.
The real answer is, I think we don't know, but I think we did it to provide a safety margin to make sure that no flashback occurs. And then the sensible thing to do is to add hydrogen. That's the easy way. The other way is to modify the injector and the venturi, which is very complicated. And then the simple solution is add hydrogen. And what I would say, since we have been using it, flashback has been a limited problem, so apparently it works.
Mm-hmm. Okay.
Okay.
Yeah. I think we can leave it there. We can, and then another question is why that? Because I hear talking a lot about the 20%. Where does it come from, or why 20% and not 30%? And also because, okay, if while the one responsible for managing the gas quality or the hydrogen concentration, maybe it will also depend on the gas demand afterwards, the changing gas demand. So there will be fluctuations probably also in the concentrations. But why 20% and not 30%, for instance? And who up to who is it to decide on that? Because I understand that TC 109 is working on the 20%, but why?
I already explained it in my presentation. That,
sorry for that.
With the 20% of hydrogen, we talk about the basically the range from 0 to 20%. And if you would go for a higher percentage, then you have to cover a bigger range. And especially when it comes to the adjustment of the boiler or the maladjustment of the boiler, you get a higher risk. And I think we saw that in the presentations today. So that was one of the reasons to go for 20%. Mm-hmm. And the second one is that it was broadly accepted by manufacturers and also from the gas suppliers. The 20% hydrogen is seen as a possible maximum value to handle. So that was the background to go for this 20%.
Okay, thank you. I see that there are comments to this from Christoph and then from Dennis.
Yeah, fully supporting what Michel said. And in addition, it's also linked a little bit to politics, because, for example, in Germany, some associations and alliances are pushing to convince politics with a clear view, let me say, roadmap, starting about using in Germany 10 to 20% in a first step and then convert to 100%. It's also a little bit linked to UK topic. And also in EHI, we have the view and push that towards Commission to get that pillar hydrogen for the heating sector considered, and with 20% also we think that we all as manufacturers could deliver a huge portfolio to convince politics to cover our heating sector, which is mainly underrepresented in national and European hydrogen strategies.
Okay, thank you, Christoph. I think maybe I would like, sorry, Dennis and Jacques, I would like to end this here because I think we can come back on this probably with further presentations, and I would propose maybe to come back on this point in the later time still for a discussion. So if you agree, I would propose a 10 minutes break. Or no, maybe 10 minutes break. Let's say that we start again at 25, so 25 past 3. Would that be fine for you? Okay.
Thank you.
Yep.
Thank you.
Okay.
So you said now 15:25, correct?
Yes,
yeah, that's right, Hiltrud.
Thank you. Hi, Jack.
Hi.
Yeah, we never know with Chris when you say the break.
No, that's true. Yeah, it's not the first time that I'm struggling with that.
I put it in the chat as usual.
Yeah, thanks.
I see the coffee,
but it's also on the slide now. Yeah, it's a very nice slide.
There is no slide. Okay. Thank you.
Yeah.
Okay. See you in 1 hour, Chris.
Okay. Welcome back, everybody. This time, because in some of the other groups, working groups, I use sometimes well, I sometimes sing. I will not do that this time because the weather is good, at least here in Brussels, and it may start raining if I do so. So now that the weather is good for once, I won't spoil it. No, thank you. Hope you had a good break. So to win some time, maybe I propose to skip the 10 minutes questions after the next 4 presentations and to do as we did before the break. So to keep the 6 presentations together and then take time for some questions afterwards. Dave, good that you are there too, and to see that you answered in the chat to the question about the 20% limit. We may come back to that later on. Okay, thank you very much. So the next presentation will be from Mindert, and as from the angle of the gas appliances regulation. Please, Mindert, go ahead.
Thank you, Chris. Thank you for inviting me. Introducing myself, I work with Kiwa. I do wear many hats. One of them, many of you may know, I wear them with pleasure. 2 of the hats I'm wearing is chair of TC109 and chair of the Notified Bodies Group. One other hat people are not aware is about renovation of our building in Apeldoorn, but that's more a hobby. But today I'm addressing you relating to the notified body of Kiwa accepting certificates for appliances using hydrogen to natural gas. So that's for the introduction. If you want to have a look at it, if we go to the next slide, please. If a manufacturer wants a certification for the gas appliance regulation, that means that he accepts liability for the appliance to be able to burn hydrogen to natural gas. That's not a research project, that's a legal project, and you have to look into the legislation to make sure whether it's A-OK. Sometimes when you ask people, have you read that book? They said, I saw the movie. Well, that's like reading standards, that's looking at the movie. But if you really want to know, you have to look at the legislation. So I will start with the legislation. 2 things are very key if you want to get certified for the gas appliance regulation. The appliance manufacturer, and that's essential requirement 1.2, has to perform a risk analysis and to make sure that all the risks are treated properly. For adding hydrogen, you must know what your appliance looks like, you must know how it reacts, and the manufacturer must therefore make his analysis because it's specific for his appliance. Once you've made it, there are a few options to deal with it: eliminate, protecting measures, or informing the users. That's how it is done. Let's go to the next slide, please. If you look into the requirements in the gas appliance regulation, I still quote essential requirements because that's the key point in the gas appliance regulation. Warning notices on the appliance and the packaging and in the installation instructions must state the type of gas to be used and the appliance category. This is a legal requirement. As hydrogen to natural gas is not standardized yet, a manufacturer has to improvise. So we'll come back to that later, but you have to make clear what gas your appliance is suitable for. The second step is that you must provide instructions for installation and adjustment. So that's the responsibility of the manufacturer, and whatever you write down must be safe. Then we get into more detailed essential requirements, and that is basically stable ignition and a stable combustion process, 2 ERs. Key issues are there: light back, overheating, and incomplete combustion. And there, which is not in the essential requirement, but wording from my side, one must consider the instructions for adjustment when making assessment here, because others have already said adjusting is a key point here and a key risk. Fourthly, to be honest, you have to look at the materials. They must be suitable for hydrogen. Others talked about it. And finally, there are some risks that are typically already identified by those manufacturers who already have a certificate on their gas appliance. And that's location of the fan, ionization current, delayed ignition, and surface temperatures of the burner and its surroundings. That are key issues that we have to consider. Can we go to the next slide, please? For the type of gas, we have a problem because there are no standards yet. What was suggested to TC238 but not accepted or not in the standard in the near future is to at least make clear for what wobble range the appliance is suitable and for what amount of hydrogen concentration the appliance is suitable. What we suggest as a notified body is to use two parameters, a Y and a Z. Let's first go to the Y and then to the Z. The Y indicates the amount of hydrogen that can be added to the natural gas, the base natural gas. And a Y20 would mean that you have 20% of hydrogen, and a Y30 you can calculate. That would mean that you have added 30, and a Y10 of course 10. The second thing is the Wobbe index variation of the base gas, the real natural gas, because natural gas does not contain any hydrogen. That would be unnatural. But if you add it, that's hydrogen to natural gas. So the base Wobbe variation is a key issue because that will be relevant in the adjustment procedure of the appliance. What is suggested to use is Z and the variation in megajoules per cubic meter divided by 10. So Z20 basically means a wobble bandwidth of 2.0 megajoule per cubic meter at 1515. Let's go to the next slide. And that's a little intermezzo because that's a difficult concept to explain, not the Wobbe index, but the Wobbe bandwidth. It basically comes from the Sector for Gas Quality Control, where we are looking for standardizing the gas distribution gases. And one of the options we have suggested is to declare the Wobbe bandwidth as one of the key parameters. In the past, the assumption was basically that the gas quality didn't vary too much. So we only used one reference gas, and that reference gas was a model for the gases distributed. If you look at the Sector for Gas Quality Study, I don't copy the graph in because I think it's still not public yet. Of the 250 grids that were investigated, the majority had a variation of less of 2 megajoule, so that will be a Z20. Some go up to even 3.7 megajoule, and there are extremes, especially in the Netherlands and in Romania, which go even up to 5.7 megajoule. So giving these indications will give you a clue where the appliance is designed for. Let's go to the next slide. So basically, these parameters could be used in the appliance category. We nowadays have the 12E that could become 12E YYZZ. If you add 20% of hydrogen and you have a bandwidth of 2 megajoule, it will be Y20 Z20. If you have a bandwidth of 3.7 megajoule, it will become Z37. You can do the same thing for H-gas. And if your appliance is designed only for minor changes, I won't define what minor is, then you can leave out the Z. And then you get 12EY, 20 for 20%, 12EY, 30 for 30%. This indicates that you are only designed for a narrow range, and the narrow range is not specified. I tried to get TC109 to agree that the narrow range should be specified at 2.0 megajoule per cubic meters, but they're not jumping the fence yet. Let me say it like that. The second thing you could do is use the Y to identify limit gases if they're used, like Michel already did. Can we go to the next slide? Michel already mentioned that you should, if you adjust appliances, then you should adjust using the O2 content. And you have to consider whether the appliance is likely to be adjusted. Mention a few reasons why they may be adjusted even if the installation instructions prohibit you to adjust them, like in Belgium, national requirements on CO emissions, national requirements on flue losses, and people may be forced to choose to adjust the appliance or to throw it away, and usually money prevails and they say, well, adjust it, that's okay. So we have to consider that as a manufacturer, how likely will it be that it will be adjusted? And a point I have to make is that adjustment instructions could be improved if the actual information on the Wobbe index of the base natural gas and the hydrogen component were available on a city-by-city basis for installers. This is not the case today, but if that is the case, proper adjustment could be made on site and avoiding improper adjustment. Let's go to the next slide. And now we go to what adjustment means in the field. And basically what we're saying is, if you have to do adjustment on the appliance in the field, you have at least two extreme situations. Let me say a high wobber day or a low wobber day with a lot of hydrogen. And on both days, adjustment could be made. So the test protocol must make sure that both settings will result in a safe appliance. And even if you set it at the high wobber index, then you must test at a low wobber index to make sure that it remains safe. And if you set it at a low wobber index, you must test at a high wobber index to make sure that it remains safe. So that's what has to be done by the appliance manufacturer. Let's go to the next slide, please. One of the discussions we were having is, what safety margin do you need for the assessment? Basically, what we have today is limit gases for natural gas. And of course, this natural gas does not contain any hydrogen. So the safety margin is added to include risk of wear and tear and variations in climate conditions and even some maladjustments. So for the appliance manufacturer who wants a certificate, he has either to provide evidence that he has a similar safety margin in his appliance, or, that's an option of course, he can provide evidence that the safety margin provided by the current test gases are over the top. And if he can provide that evidence, we no longer need those test gases because they're above and beyond the legal requirements, and then they can be skipped. That would be a little bit of opening Pandora's box, but it is a possibility that the manufacturer has. If he doesn't want to do that, then he has to make sure that he has the safety margin. Let's go to the next slide. Assuming you want to maintain the safety margin, then basically for and there I use the letters which I defined before, if you want to add 20% of hydrogen to an appliance that has limited variation in the Wobbe index, you could easily say, let's use G20Y20 as the second reference gas and use G22Y20 and G24Y20 as the lightback gas, as the additional lightback gas and the additional overheating gas. That will give you the impression that you have more or less the safety margin. If you want to go for all the way and say, well, my appliance is able to deal a Wobbe variation of the base gas without hydrogen of 5.7 megajoule, and on top of that, I want to add 20% of hydrogen, well, you will have to make an assessment how to test that. And it's my belief that this assessment will very much depend on the instructions with the appliance, the mixing method used, and the burning technology used. So it will be difficult to make a general purpose assessment there. Go to the next slide, please. Risk we identified in the risk analysis, and we'll go quickly through them. The location of the fan, especially if the fan is in the gas-air mixture. Well, the question is, what happens if it ignites? Will it fly 20 yards or will it only do a big poof? Well, if you as a manufacturer have ensured that people are unlikely to be killed by it, then you have at least eliminated the risk. Flame supervision device, you mentioned it. Delayed ignition test, we would recommend to do delayed ignition test anyway, regardless of the safety times, just to make sure that there is no risk. And finally, surface temperatures are a key issue, especially for fully premixed appliances which burn in the red flame mode. That means radiant combustion. They can become hot, and if you add hydrogen and adjust the setting, then it can become even hotter. So that will be a very key issue. What we have seen from assessment by manufacturers who are measuring the temperature, of course, is that changing the air ratio or the lambda is a good way of simulating what happens in the field. Let's go to the next slide. That will be my first conclusion. To summarize it all up, instructions must be clear on the gases the appliance is designed for, and we have the Y and Z as an option, but you can do it in another way. There's no standard yet. Manufacturers must provide a risk assessment. You must provide evidence that it's just as safe as a normal natural gas appliance. And key elements are, and I mentioned them, and I underline one because that's key, on-site adjustment of the appliance is a thing that is not to be overlooked. And now I go to lobbying mode. If you go to the really last slide, what would help? If we want to introduce hydrogen to natural gas, it would be very helpful if there's accurate, actual information on the Bobby index of the natural gas only gas and the amount of hydrogen in the gas on a city by city basis, open to installers, so they can use that for setting the appliance. This is clearly not the case today, but if that is in place, it will be helpful. Of course, this may require national legislation on DSOs and TSOs to be adjusted to make sure that they're responsible to do so. But if that is in place and the legislation is in place, the manufacturer may assume that this information is available and can instruct the installer to use it when adjusting the appliance. So that would conclude my presentation.
Okay, thank you very much, Mindert. So that it's also good to have a look at it from the angle of legislation instead of only standardization. So thank you very much for that. I see that Jacques has a comment, but Jacques, I prefer that you also keep it for the discussion at the end, please. So next would be, because we are behind schedule, so the next presentation would be a presentation by Mr. Dennis Klein from DVGW, so from DVGW's experience so far. Please, Dennis.
Yes, good morning, everybody. I try to save some time and do it very quick. My name is Dennis Klein. I'm working for DVGW, Standardization department. And I'm an expert on gas appliances and working on the standardization in this topic. And our sister or daughter company worked on a certification program. Please go slide back. Yes, that's called ZP 3100, and it's an additional testing protocol for gas-fired central heating boilers using hydrogen mixtures up to 20% hydrogen. So now, next slide. Let's dive in. So first of all, why did we develop such a protocol? There was an increasing demand from manufacturers for the possibility to certificate their appliances for the usage of 20% hydrogen and mixture in natural gas. And there was no standard available. We're working on it. But in the meantime, there must be a solution to use these appliances. Our protocol is based on research in the state of the art and is a living document, so we are constantly working on it. But for the time now, it's finished. It's part of the DVGW strategy. We have a two-step roadmap to implement hydrogen in standardization part 1 are guidance protocol and protocols to ensure that you can use everything in a safe way. And part 2 is the total revision of all existing gas standards that can be used then for hydrogen and hydrogen admixtures. Next slide. Thank you. So the ZP 3100 is a testing protocol which is based on the EN 15502-2-1. It's an addition, so you can't use it on your own. And it only explains the additional tests which are affected by hydrogen. There are also some new reference gas and test gases provided, which are also explained by Michel in a way before. I come to this part later. And one additional thing you also need are components, parts, and materials need a declaration of the manufacturer that they are suitable for the use of hydrogen or hydrogen mixtures. The structure of the certification program is a big table, which on the first side tells you which clause in the EN 15502-2-1 is changed. It tells you what the new requirement is for the up to 20% hydrogen. It tells you how the test conditions differ. And then there are some comments if there's something special you need to consider. And on the last part, which test gas you have to use for the new test or the additional test. Next slide. The protocol was developed by our German experts from the testing laboratories, some manufacturers and notified bodies. And it included research and testings of the aforementioned experts. And it was used to support the amendment of hydrogen for the EN 15502-2-1. So it will, as you can see with the presentation of Michel, there are not many differences. There are, of course, some differences which are in the proposals, but we try to bring all our knowledge and gained expertise in this topic into the standardization. We also bring the new gained knowledge into the revision of the EN 437, so for the new test gases. And the ZP 3100 is already published. It was published in last year in October, I think, and is available for free under the link that you find there. And if you want to know more, I guess you download it, it's free. And if you have something to change or some questions, just ask us and we will then try to answer. Next slide. And just something for the next steps ahead. We are also developing test protocols for new appliance or other appliances that can use up to 20% hydrogen, in this case for fan burners. There's a working group that's working on it. And also there's a new test protocol that we are developing with the experts for the use of 100% in boilers, also based on the EN 5502-2-1. And I hope it was short enough. I saved some time. Yes, I got 2 minutes left, so I guess thank you very much. And I'm here for questions. Also, my colleague, Mr. Kinn, is in the chat. He's the secretary of the group. So if you have some questions or maybe you want to join us with your expertise, then you write him. Thank you.
Okay, Dennis, thank you very much. That was a clear presentation, and I think you even still have 4 minutes left, so that's fantastic. Thank you for that. So okay, then we'll keep the questions also till later on. So next presentation we have is we switch now to well, some experience that exists already at manufacturer side. So there is first Sebastiano Temperato from the BDR Termea group. Please, Sebastiano.
Yes, thank you. Good afternoon to everybody. My name is Sebastiano Temperato. I'm the R&D laboratory and approval manager of Baxi SPA. Baxi SPA produces gas boiler, and it is part of BDR Termea group. So we can go on with the slide, Alexander. Okay, so Baxi SPA has started the activity to develop gas appliances operating with pure hydrogen since 2015. And in 2016, the Baxi Lab has been provided of all the facility to operate with both pure hydrogen and natural gas and hydrogen blends. So it's possible to see in the picture a box where we have two electrolyzers, where it's possible to produce the hydrogen that is needed for lab. We have a new box where it is storage the hydrogen bottles and the mixing station in order to provide all the percentage of hydrogen in the natural gas. The first boiler with the working with pure hydrogen has been approved for field test in beginning 2019. It has been installed in Netherlands in June of 2019, and it is still working today. Other boilers are working also in UK for the I48 project, also in Netherlands, and very soon will be installed also in France and in Germany. Please, Alexandra. Okay, so as we know, hydrogen is a gas that is very different compared to natural gas, and its future, like the high flammability range, the low ignition energy, the low density, the high laminar burning velocity, the high heat of combustion, and the high detonation sensitivity and pressure rise can represent some risk. So the H2 boiler should prevent any explosion outside the combustion chamber because of gas leakage, any emission of gas admixture before the burner, and any flashback also in case there is a wrong lambda. So the new European standard that has to be defined for this type of boiler should consider all these risks, and in our opinion the PAS 4444 is a good starting point for the assessment. In this preliminary phase, an incident in the field will not be accepted, and in our opinion the available technology should be used to prevent any safety risk. Please go on. So different is the story for natural gas plus hydrogen blend, because this is not new in our business. Gas boiler operated with town gas for many years in the past in several countries like Europe and also China, and most of the gas fittings are already suitable to operate with natural gas plus hydrogen, and most of these components are already approved also today for the first gas family, G110, that has 50% of hydrogen. In Europe also the use of hydrogen in the natural gas grid is already authorized in some countries for low percentage of hydrogen. The main concern that we see connected with the use of hydrogen in the natural gas grid is the fluctuation of the hydrogen volume in the blend. So our recommendation is to limit the maximum amount of hydrogen to 20% because of this reason, because we need to consider the risk of wrong setting in the field by service people, especially for fully premixed boiler, because it is possible to set the gas valve in the field when the gas has a low VOB index, so the percentage of hydrogen is the maximum, and after the boiler can operate with natural gas where the VOB index is higher. In this condition, the boiler works in overload, the CO and also the burner temperature and increase. We need to consider also the risk of the late ignition, especially when the boiler is set to operate with the maximum amount of hydrogen and the lambda is the nominal one. Other thing is the heat output and the comfort reduction for the end user. So with 20% of hydrogen, the reduction is circa 5%, that for us is acceptable when we consider a maximum percentage of hydrogen of 20%. Okay? So some consideration about the flashback. Flashback is never an issue with a premix boiler when they are set to operate with natural gas. So also with 60% of hydrogen, the flame speed remain low because of the reduction of the VOB index and the increase of the lambda. So flashback could be an issue, increasing the percentage of hydrogen only if it is associated to a reduction of the lambda. So lambda is the most important parameter to consider for the evaluation of for the operating margin of the boiler. We have made some experience also on electronic combustion control based on ionization current that don't seem to react to the VOB index change in case of presence of hydrogen in the blend. This behavior could be positive because it avoids any risk of maladjustment or adjustment in the field by service people, and the boiler operates always in a safe condition. Moreover, boiler with a very high modulation ratio operating at minimum power could have problems because the temperature of the burner increase a lot and the flashback could happen more likely. Okay, so now we have here some consideration as per THyGA request for this meeting. So in this moment, Baxi is directly participating on several working groups connected with hydrogen, like THyGA, I4IT for UK, TC109 DOC working group for hydrogen, Asothermica Green Gas Group, that is in charge to develop a test protocol for manufacturer for the evaluation of the boiler that are already in the field working with a blend natural gas plus 20% of hydrogen. Also, the UNI mirror group that in this moment is in charge to develop a test protocol for the approval, for the certification of the boiler that can operate in the field with 20% of hydrogen. And also, we have a relation, of course, with the notified body that assists us on the certification of the Baxi product that are already in the market with 20% of hydrogen as blend. So the risk associated to the use of natural gas plus hydrogen, as described in these slides, are not, in our opinion, a blocking point for the introduction of hydrogen in the natural gas grid. The use of a limit gas to verify the operating margin for the flashback, we have spoken before about the G22 as defined per TC109 in case the maximum percentage of hydrogen is 20%, and this is consistent with the approach used today with the EN 15502 standard. Something about the eco design and the energy labeling should not be impacted, in our opinion, by the use of natural gas plus hydrogen blend, at least up to 20% of hydrogen. Same approach should be used also for other applicable legislations. Last slide. So something about the CE approval. While the new boilers will be approved, for boiler already in the market, it remains an open point. The field responsibility should be defined. The CE approval of all installed appliances for us seems unrealistic. A manufacturer's declaration, together with safety instruction, should be, in our opinion, the minimum requirement in case hydrogen is between 10 and 20% in the gas grid. All the running products that are not approved according to GAR or GAD should not be considered, in our opinion, for to use a hydrogen blend in the field, and so should be replaced. Regarding the use of a retrofit kit, as requested by THyGA, in our opinion, should not be a problem for new CE approved appliances when the kit is part of the certification, of course. For our experience on our boiler, there is no need of retrofit in case of the use of the blend natural gas plus 20% of hydrogen. And if it is not mandatory to certify the already installed product in the field, in our opinion, also the use of a retrofit kit should not be certified, but just authorized by the boiler manufacturer. So that's all from my side. Thank you very much for the attention.
Okay, thank you very much, Sebastiano. I think it's very important to see what manufacturers think about all of this, because as we as notified bodies, test houses, etc., can have our opinions, but of course manufacturers are key in this discussion too. So the next one is from a manufacturer's point of view, but from another type of appliance. So that is from cooking appliances. So and that will be presented by Maurizio Beghi. Maurizio,
thank you
please.
very much, Chris. I hope that you hear and see me.
Yes, absolutely. Thanks.
I will try to spare some time for you. And of course, many of the previous items that we heard during the presentations are common for us as well. So I will go just through some hints, please, next slide, for discussion in this meeting. Well, our appliances, of course, they fall under the regulation 426 and also the 65 and 66 for eco-design and the energy label. But I'm supporting what Midland said at the beginning of his speech, when he said that product certification really is not possible without modification also in the legislation activity. This is really fundamental for the manufacturers. Well, we actually have a number of appliances for domestic and professional cooking, barbecues, catering, gas dryers, professional gas dryers, and water heaters that can have an impact by this new gas supply. And I'm not talking about only the technical items and issues, but also about the commercial and how we can present our product to the market. We need to think about what's the meaning and the content of H2 ready or H2NG compatible products and ranges, because we have really also a stronger sustainability target in our strategic intent to reduce the combustion and the carbon footprint and emissions. And if you consider that today 80 or about 90% of the total carbon footprint of the product is made by the usage, we need really to think about how to manage this type of leverage on the market. The next question is about how can this use of hydrogen impact the sustainability or the life cycle assessment of the product. This is a question that really need a little bit of calculation, also considering what's the actual impact of the production and distribution of the hydrogen, if it is from green sources and energy, or from oil, or gas reforming, or coke. And also we are having a discussion about different scenarios in relation of how we have to adapt or modify or retrofit the products. So we can think about simple factory presetting, like what we do today, for example, with sort of bypass for a minimum setting, or simply using on-site adjustment with some kit, including maybe just the injector, or we could also have some conversion kit, so need additional part replacement like the gas burner or the gas valve. We don't have to forget that our components for the gas product are not really controlled with an air gas regulation. So we have a fixed geometry, and not only the gas burner, but also the injector and also the gas valve. So actually, we could need a replacement of some of this part if the increase in the percentage of hydrogen can have an impact on it, up to giving a real specific design for a higher hydrogen percentage. Please, next one. Well, actually, About the hydrogen blends, there is a lot of discussion also in Italy. In Italy, we have a new government since a few months, and there is also a new ecological transition ministry. This ministry has a very strong target of improving our innovation on the energy and on the ecological transition. And we are discussing about hydrogen gas and then also the nuclear energy management as a new stream of the development and the innovation. There's also a lot of money available now in what we call the recovery fund to recover from the current crisis that we are facing due to the virus. And there is a lot of activity also trying to find some guidelines for the usage of hydrogen. But there are still a lot of doubts about the infrastructure, production, and also transport and distribution of hydrogen. Still is not clear the situation, and I think it's a little bit fragmented in Italy. But our question now is, other than what would be the percentage in Italy, is there any potential issue with different national approaches to this type of percentage that can make confusion between the percentage variation country by country? This can have an impact on the manufacturer, because if we have to state a different type of gas country by country, what also Minden said before, for the certification of appliance, it can really multiply even within Italy, within Europe. Other point, and this is more a question for the team, are all hydrogen sources the same? Is there any difference maybe in the gas composition or the purity of the gas that could have an impact on some performance parameter of our products? This is, to me, still an open question. And then what about the appliance already on the market? What type of strategy we shall apply for them? Do we need to support our selling with specific labeling for the product, or shall we, as we said, prepare a retrofit kit? And backward to what time? I heard that Sebastiano was suggesting a limit in time for the product, not before the GAR to be retrofitted or used. Then this could be one limit point. And we are working also with the Technical Committee 49 that is showing a lot of interest in this type of activity on hydrogen, but not really area specific activity running so far. Next slide, please. This is my last slide, where again, certification, homologation, or even a backward compatibility could make a difference for Electrolux in the type of business model that we have to use for the adaptation of the appliances. And the note on this is that if there is an uncertainty about what could be the strategy for the introduction of hydrogen in the main pipeline, well, this could also lead the consumer toward the electric appliances. So we should be very good in informing the end user that there are no potential risks, that there are no problems for them, and that they can use as normal the appliances as they did before. Another point is about the supplier competence and component readiness. We as manufacturer are working on the subject, but what about the suppliers? So the supplier base is also not coming only from the European area, where probably this will be an incentive for the supplier to work on the subject, but it's a global supply. So how we can be sure that our suppliers are working together with us to prepare the components and the parts for the introduction of hydrogen. We already discussed about the component readiness for hydrogen versus town gas with Martin at the beginning of this meeting. And the last point is about some practical activities during testing. legislation could also bring some limits about unbound hydrogen or hydrocarbon or NOx, different from what we are testing and facing now. So also our way of making the tests, both for combustion and leakage, shall adapt to the new type of regulation. And also our components or our test benches shall probably be adapted to the new type of gases. And that was the last bullet point. I hope it was quick enough.
Yeah, thank you very much, Maurizio. So I think that was clear. Thank you for sharing these your views and concerns with us, of which many of which I share, by the way. So thank you for that. Okay, we'll move on to the next presentation. Next presentation is a presentation by Mark Crowther from Kiwa UK. So with looking to some existing experience in the high deploy project. Please, Mark.
Good afternoon, ladies and gentlemen. This is really Mark Crowther from Kiwa Gas Tech, based in Cheltenham in England. Very pleased to be with you this afternoon, and really this is a good news story from start to finish. I'll move on. This project, next please. This paper is based upon a much more formal academic paper that in fact was given in Australia, which covers all the work that we've done in this. So I'm just giving due reference to the Health and Safety Executive and to IGEM, who we co-wrote the paper with. Next. These are the test gases that we used, which you can see I won't go through in detail, but are very similar to the ones that you've all seen before. You can see that the WOBE numbers again cover and the constituents are cover the range that's expected. The client was the Cadent Gas Company, which is a big gas GDNO here in the UK, covering most of the Midlands. And for a variety of reasons, I think going back to history, they decided that 20% was the right figure. And that's what the R&D is focused around. Next, please. So we have a little graph here which shows the range of the test gases relative to the reference gas, relative to the distributed gas. You can see that the top hashed line there is the top end of the gas as distributed in the UK under normal conditions. And the bottom hash line is the lower one. And you can see the way that we chose test gases that dotted around that value so as we could be certain we understood what was going on. I think it's quite important to note this point about the actual range of the distributed WOBE number, because particularly with the top end of the WOBE number at the moment at being 51.5, by the time you're getting down to sort of 47, which is the limit, manufacturers are already taking calls on poor hot water quality, especially for people taking their showers and things. And if, as you can see by the addition of hydrogen, you start bringing the WOBE number down even lower to something nearer 46, there are implications there in terms of customer satisfaction. Next. So this was quite a limited program of work, but it sort of gave us a good feel for things. We tested 8 products there, ranging from hobs through to gas fires, through to boilers, with all kinds of partial and fully pre-mixed burners. As you can see, a couple of combi boilers at the bottom there. There was an old an old BBU unit, which is very old, even by English standards. It's probably 40-year-old boiler. There's a system boiler there, and there are some ordinary gas fires. Next. And although the typing here is small, I mean, what we basically found was just like the rest of the THyGA project will have done, that we don't see any particular problems with any of those appliances when they have been left at their original design point, where they are adjustable, which is essentially for G20. There was a question mark over one of the ODS sensors, which did perform fairly poorly, but that's probably because the hydrogen stabilized the flame on the pilot light. But really, from a risk assessment point of view, CO incidents are very rare in the UK. They're mostly related in the old days to soot falls, birds, and malfunctioning boilers. So really, it's something I think that certainly we've managed to convince the health and safety authorities on a risk basis, and we can carry on forward. Next. This is the more interesting bit of the work, where people were asking earlier about, have you had second-hand kit into the lab? No, what we did was take one of our Kiwa bottle wagons, which is a flatbed truck on the back of which we mount bottles of appropriate test gas. And we actually take that in front of a house or in front of a student block or a cafe, and we connect that cafe up to those gas bottles outside, and we test them. We test as situ performance, and you can see there we tested 199 appliances over a period of, I think, about 8 weeks, involving appliances in a whole range of locations, from flats to semi-detached houses, big detached houses, students' halls of residence, and other non-residential locations. Keele University is a large open campus university with its own independent gas supply, which is why it's convenient to be able to do test work on that site. Next. The gases that we used were G20 reference gas, and then with G24, which, as you know, contains 20% hydrogen, and test gas, one that we made up with 28.4% hydrogen, because that's the maximum amount of hydrogen you can add to G20 without going below the GSMR limits. Next, please. And again, the results were extremely encouraging. I mean, this is out of 199 appliances. This is sort of just a snapshot of the results. We found, for instance, 558 of 91 properties had correct CO alarms. They had the correct smoke alarms where necessary. The fluing was good. The combustion behaviour was all good, as you might expect with the second test gas. With the first test gas with a slightly higher WOBI number, with the propane, that's your G24, the CO content went up a little bit. And with the second test gas, the WOBI index, with a lower WOBI index, the CO levels all fell. And the combustion performance was generally as expected, although the gas input did fall, obviously, with the higher hydrogen test gas. Next. This now, remember we tested 199 appliances. In a sense, this is a little bit irrelevant to the THyGA project, but it does explain there were just two locations of that 109 where we found maloperation. One was a build-up of grease in a cooking facility, and the other was a boiler in residential property. But let us stress, there would have been no difference to the outturn risk whether or not gas with added hydrogen would have been distributed or not. Next one. Again, we did some gas tightness testing, and we found there was a very old meter there with some lead pipe connections which were replaced. There were some other minor defects, but again, none of these defects would have materially affected the risk posed by the gas installation when we made the change from natural gas to natural gas plus 20% hydrogen. Next. And again, this is tightness testing of the actual downstream networks themselves. We did find a domestic property with a small leak on the hob, but again, nothing material would have arisen. In the Science and Learning Centre, there was a small leak on a gas governor, and in the sports hall again, there was another leak. But really, these are not material, and I only report them because it's important that, if you like, for 199 real appliances, these are the real defects that we observed, and the effect of hydrogen on none of them would have been material. Next. So the conclusion was a detailed lab-based program of work has been undertaken to investigate the effect of hydrogen injection into a natural gas-based distribution system with hydrogen up to 20%. And basically we found no significant problems at all. Minor concerns were identified on the use of ODS standardization detectors, but the majority of test data indicate no deterioration in public safety when using a hydrogen blended natural gas mixture. I've been very quick, but really I just wanted to sort of give you this what we perceive to be quite a good news story involving quite a large number of boilers on real sites. Just a final point about the variability of gas, particularly as in the UK, where some of the gas companies are pushing to have a base Wobbe index range of 6. By the time that you have that and then you start adding 20% hydrogen to them, we really do think it's important for us to publish the fairly accurate sort of real-time values of Wobbe index and distributed and hydrogen, because without that information it's going to be quite difficult on some of these existing appliances, particularly the larger commercial boilers, as used in some of the big student blocks and things. It's going to be quite really commercial stroke light industrial. It's going to be quite difficult to set those up at good efficiency without that information, and that's certainly the feedback that we get more from our commercial and industrial colleagues. In sessions like this, you can get very focused on the domestic sector, but the commercial and industrial people obviously want to set up their boilers, are hired to set up their boilers in the most efficient fashion, and I would suggest that if they don't know what's coming down the pipe, it will be increasingly, at any particular time, it will be increasingly difficult to set those boilers up efficiently without that knowledge. Thank you very much.
Okay, thank you very much, Mark. I think that's very interesting to see what happens in the field. To be interesting to examine probably whether the conclusions can one-on-one be applied elsewhere for the existing stock of appliances. But very interesting. Okay, then. Last but not least, we'll move to Ted Williams' presentation from the American Gas Association. Please, Ted, go ahead.
Thank you, Chris, and thank you, THyGA, our partners, for inviting me to participate in this event. Very interesting. I am a Senior Director of Codes and Standards for American Gas Association, which represents over 200 gas companies in the U.S. But my remarks today will deal with really North American standards, and that the Standards Secretariat in the U.S. for the U.S. standards is essentially also for Canada. And so we talk about standards, and many of you are familiar with the standards structure in North America is around the Z21, which are residential appliances, and Z83, which are commercial appliances. But in any case, if we could go to slide number 3, Alexandra. And just start off a little bit. I've learned a lot more than I could ever teach you in this workshop. I think this is an important event for us to catch up on what the THyGA project and other things are going on in Europe are doing. Essentially, we're a fairly primitive stage when it comes to hydrogen blending, and essentially what we work at through the CSA group is bringing together manufacturer, regulatory, and gas supplier interests around the harmonized standards for North America, chiefly U.S. and Canada through the Z21 and Z83 standards. But some essential parts, description of the U.S. gas market needs to be included in any discussion that we undertake, and it really is the size of the market. We're talking about over 70 million residential customers in the U.S. alone. That including essentially multiple gas appliances in each residence, 3, maybe even 4 gas appliances. Commercial is also quite large. I think with respect to the residential appliances, we're talking about a very large percentage of partial premix atmospheric burner appliances. And the issues there become essentially with all that installed infrastructure, changing out with more modern appliances, maybe that are more suitable for handling hydrogen mixtures, that you do that one at a time. You'll probably retain one of those partial premixed appliances for quite a period of time after you start replacements. So it's a component of the U.S. gas market that we can't ignore, and certainly manufacturers of new appliances are concerned not only for a hydrogen operation on their new appliances, but also appliances they have in the field now. And in the U.S. Being a litigious-oriented society, potential lawsuits around problems with the installed appliances that may have been sold some time ago. Another aspect of U.S. markets, I think it's important to emphasize the increasing networking of flows of gas in the U.S. Supply system. One of the early presentations talked about plug flow of gas supply and how the composition may change for a given appliance. Well, that can happen 2 and 3 times a day in the U.S., and you may see fairly dramatic changes in the gases that hit those appliances and are consumed by those appliances over a short period of time. The changes may be immediate, they may be gradual over a period of hours, but nevertheless, it changes. And the more change you introduce by different sorts of gases, including admixed natural gas and hydrogen, may create issues that hadn't existed before. But that network issue is no longer a case that gas flows from the Gulf Coast of the United States up to consumer markets in the Northeast. That is not the reality in the U.S. anymore. In terms of what the U.S. has done, Howard Levinsky's on the call. He was a consultant for us back in the 2000s when we were doing work on gas interchangeability, when the prospect at that time was importing LNG into the U.S. gas market with quite different compositions than domestically produced gas, and engaging in manufacturers and testing at that point to determine how much variation could be tolerated by the appliances in the field and then under existing Z2183 standards. And so there's experience in the industry in doing this kind of work. We were talking about a different sort of issue of new compositions to deal with at this point, but nevertheless there is some familiarity, and everything we do is to bring the manufacturers along with us. A lot of the effort on hydrogen, as I'll explain, is driven by gas suppliers and commitments gas suppliers have made, but we're not going to be able to do anything without the involvement of the appliance manufacturers in this area. Okay, Alexander, can you go to slide 6, please? And essentially, what we have in the U.S. is really much more than an issue of introducing hydrogen admixes into the gas system. It's a whole subject of what's called renewable gases, or RNG, or renewable natural gas. The definitions are only now becoming solidified. I provided on this slide a definition that's being completed by ASTM for the U.S., and this includes hydrogen admixes. But we're talking about very different compositions for in that family of renewable gases. We're talking about municipal waste gases, which include a lot of inerts, including agricultural waste, which can be very high in methane and essentially no hydrogen. And so all that, those concerns are being touted as carbon reduction strategies overall, in addition to power-to-gas operations that would produce hydrogen and allow us to admix with hydrogen. So we have to deal with these issues simultaneously, and they're being pulled in different directions. It's not purely an abandonment of methane. And then finally, that we have in the U.S. a very regulatory intensive program that treats individual states much like individual countries, where the agreements on trading gases across state lines in the U.S. are subject to tariff negotiations, and essentially interchangeability has to be demonstrated. This is a very much an interventionist sort of system where a party at one end of the pipeline may object to a certain gas because of their end use, and can have a very detrimental effect on the actual trading of those gases under existing tariffs and pipeline contracts. And so this is an aspect that I really am involved with from the technical side as well as up into the regulatory. We have to deal with these things simultaneously. Go on to the next slide, which I believe is slide 9. And I thank you, Alexander, for getting through this. Yeah, just get into the testing that we did perform, and we are very far behind what the THyGA projects are involved in. When we started off, and this was a project initiated by AGA to get the manufacturers involved in this early, recognizing that some of the AGA member utilities have already made commitments to put in hydrogen into the gases, that we needed to do what we thought would be an exploratory testing program without any preconceived hypotheses on what would actually happen. We had some technical ideas and certainly background from the European experience and so forth, but actually to really follow the C2183 standards, which the appliance manufacturers are familiar with, and evaluate operations for a number of those tests in terms of combustion safety and other operability against those standards when we tested with hydrogen in the fuel gas. Our tests were based on mixes of methane and hydrogen because we wanted to make sure that we didn't have a variability of natural gas component come into our testing program. The testing program was administered by the Standards Secretariat Research Group, CSA Group, the Air Conditioning, Heating, and Refrigeration Institute was a co-sponsor, as well as AGA. And the testing has been completed. We got the test complete, the report done. We're now working on finalizing the report from CSA Group, which should be published in the next month. Okay, we go to the next slide, please. Essentially, this is an illustration of the kinds of results we achieved from this exploratory testing. We tested a total of 12 appliances across 4 different appliance categories, residential appliance categories. And we used admixtures of 5% and 15% hydrogen because those were what the utilities had made commitments to, specifically in terms of a target in Southern California by 2030 to have 5% in their gas supply, 5% hydrogen, but also talk about 15%. So we don't go higher than 15% in this exploratory program or in our plans going forward because gas suppliers are not essentially proposing to go higher. You know, there's good technical arguments we've heard in the previous presentations for going for higher blends, but nevertheless, we're not going to get too out in front of what the utilities say they are willing to provide. And we have a list of conclusions here, and essentially you'll see no. Essentially, we didn't see effects on performance of the appliances in terms of emissions or critical safety issues from these kinds of admixes when performed in the C2183 standards for safety tests. And so not a big surprise, although I will point to the last one. Pilot ignition was observed in one a space heater to be a problem, also a boiler. And that raises issues, I think, that Mark suggested in one of his presentations about, I think in the space heater, our concern is over essentially ODS devices, which we have as many as 40 million appliances, embedded heaters in the U.S. Appliance market currently that use ODS technology. So reliability of the ODS is quite important to us. And then also basic pilot behavior and behavior more generally for partial premix burners. Next slide, please. Okay, in terms of what we took out of the exploratory testing going forward is that we felt was necessary for us to go back and do take a look at essentially real gases, and not just methane blends. And you know, this goes to the issue really that the U.S. has never been, and this goes back over 30 years. The American Standard Scheme has never been around limit gases. There was a decision made quite deliberately in the 1980s to not essentially revise the testing of appliances based on limit gases, but instead retain a system of test gases around which performance we evaluated. And you can make an argument that the 8 test gases that are used in the U.S. system represent limit gases collectively. However, those test gases are not all applied uniformly for all appliance behaviors. And so it's not really a clear correspondence to what's done in Europe in terms of essentially limit gases. But we essentially want to look at combustion behavior in particular in performance under the standards for safety, and that we have some consensus over what is a representative gas in the U.S. With fracked gas and other sources coming into the system. There's an increasing question on what is a typical or average natural gas in the U.S. gas system. Very hard to come to consensus on that. And then how to implement essentially that consensus on what gases should be used for the blends and appliance testing and certification. And I'll talk about that at the end of the presentation here a little bit more. But we really, I think, going forward in the near term, want to focus on diffusion flame or partial premix burners, because we think that those are certainly a very important part of existing appliance infrastructure as installed, and then also it continues to be part of the appliances that are sold into the market. Some refer to this as legacy technology, which I think we find somewhat objectionable, because it's essentially there in certain circumstances the cost-effective approaches that meet consumer needs. And then looking at those considerations in terms of what that means in terms of the new products and where products are trending. But I think this focus really to look at diffusion flame or partial premix burners is important. We have enlisted some consultant support for this. I got in full disclosure, Howard Levinsky's on the call. Is our combustion consultant is helping us work through some of these issues, and that we really want to look at certified tests versus field performance, particularly with respect to pilot ignition and unstable pilots like ODSs in appliances as something in the near term to be studied. Near term, we're also looking at a program with a major Canadian utility for looking at used appliances, if you will, appliances taken from the field and brought into the testing laboratory. And I'm very interested in learning more about the THyGA efforts on long-term testing and how performance will change over time, because I think those mechanisms are something we want to track in any used appliance work we work on. And certainly, and also cooking appliances. I think you had some comments from the earlier presentations about cookers and the essentially issues of flashback involved in cooking appliances, and we see this very important. To date, we have not had the association representing the cooking appliance industry involved in this, but they are increasing interest in this and may be joining our efforts going in the out years. And then potential standards actions. We're getting ahead, I think, of the process a little bit, in that we're actually considering a proposal for combustion performance and actually looking at leakage in appliances in the Z2183 standards by proposing a test gas. And if you have the next slide, please. Essentially describe the fact that we had not gone forward in the U.S. 30-some years ago in the limit gas approach. Instead, looked at a family of test gases, which are shown below, and they're only characterized in that table 12 in terms of the gross heating value and the specific gravity. Well, it's essentially a Wilby number designation for the gas, but those essentially are the gas characterizations around which performance is evaluated. They're not upper or lower bounds for gases, and essentially because they are administered differently, that not all tests are applied for a manufactured gas, for example. But this really is something we want to work with in the existing standard structure for introducing essentially a limit gas concept into the North American standards. And so we've identified the central furnace standard for the U.S. and Canada, Z2147, the CSA 2.3 standard, as a means of developing the discussion around introducing hydrogen admixes, and we will do that. Essentially, our plan in discussing with some fairly senior people within the Z2183 community, looking at replacing what you see in there. It's a little hard to read, I apologize, but is test gas B, which is a manufactured gas, which is really no longer relevant for the U.S. gas system, but replacing that with a 15% admix of hydrogen and natural gas. 15% we think is sort of the sweet spot around which certification testing can be agreed to. We think the manufacturers can be comfortable that that is a a reasonable effort. It won't arbitrarily fail appliances, and it also is consistent with what gas suppliers are willing to commit to at this point in time. So, and that may change over time. We could go up to a 20% if there's some technical justification for it. But in terms of introducing hydrogen admixes into the standard system, we think a 15% proposal is probably the best place to start. Okay, I believe that concludes all my slides, and I'll take any questions you have. Thank you.
Okay, Ted, really thank you very much for this presentation. Interesting to see because yeah, I have some experience myself, although it dates from easily 20 years ago with testing also in the United States and Canada. But from what I remember, it is as far as test gases are concerned, it is significantly different, and the approach is interesting. And I think well, it interests me, but I think also the project members to get a little bit deeper into that. But okay, not today. So thank you very much. I didn't know neither that there were also these cross-border issues, cross-border gas quality issues between states. So we have a lot of experience on that in Europe, as you probably know. And
Yes.
but maybe we are not the best ones to look at, although we made significant progress in the meanwhile. But it took quite a while, also easily 2 decades. So okay, I think that brings us indeed to the questions. So if there are any to Ted or the previous speakers after the break, please. But maybe I want to give priority to Jacques and to Dennis, who also had questions before and who I asked not to ask their question at that moment. So Jacques, Dennis, do you still have your question or your remark?
Yes.
Please.
Thank you, Chris. First, I have 2 short questions, but a first comment. I'm very pleased to see that what started some 4 years ago as a somewhat lonely endeavor to win over the support of Hydrogen Europe, of the European Commission, and of Hydrogen Europe Research, who are the governing bodies of the fuel cell and hydrogen joint undertaking, were successful, and that FCH JU decided to place several calls on pre-normative research for H2NG, and especially the one that I drafted with the help of several of you to let's say deal with gas applications, or the impact of H2NG on gas applications, and for which THyGA successfully answered. So I'm very happy to see that now so many of you are committed to that, and this is good news for the let's say the gas industry towards the energy transition. So this was my comment. I have one question for Mindert, which relates to on-site adjustment, and how can we ensure that it will not lead to what the German call as Verschlimmbesserung, so an improvement for the worse. And my second question is to Ted regarding the let's say regulatory level of NOx emissions in the US, because in Europe for, let's say, fully premixed burners, it's below 15 milligram per kilowatt hour.
Maybe thank you for your comment, Jacques, and then also for your questions. Maybe I see that Ted is on the screen, so maybe Ted, can you answer to us?
Yeah, the U.S. regulatory scheme for residential and commercial appliances does not cover NOx nationally. There are requirements in various states in the U.S. for that, the state of California being the one with the longest term limits, and it's based on a different sort of calculation. It's based on essentially milligrams per megajoule of energy input, or energy output, I'm sorry. it's very hard to translate that into some of our other emission factors, but it's only in that jurisdiction and a handful of others in which we have NOx limits. There are NO2 limits for a given product, such as unvented space heaters, and so we have to treat oxides of nitrogen differently depending on the class of appliance and the location in which it's installed. In terms of the correspondence of total NOx to the European standards, I would need to go through some calculations to show you how the California requirements might coincide or differ from what's affected in Europe.
Thank you.
Okay, thank you. Then Minder, do you remember Jacques'
yes,
first
I
question?
remember the question. I'm old, but not that old.
Yeah, but I'm allowed to say that. I'm.
Yeah, you are. The problem is that there are two things. Appliances using gas-air ratio controls have a zero pressure regulator that drifts. And because it drifts, there's a tendency to make sure that it works okay. And therefore, some manufacturers specify in their instructions that you shall adjust your appliance. And of course, you can throw it away, but usually then people want somebody else to pay for a new appliance. So that will take place. On the other hand, experience shows that even when the manufacturer forbids to adjust it, by putting a pot of paint on the screw, 50% of the appliances have been adjusted anyway, because they don't comply to the Belgium requirements on CO. So then the option is no heating, or turning the screw and put a new pot of paint on, which costs 15 cents. So the choice is easily made. The other thing, there's also a requirement on flue gas heat losses. So you have to make the decision there. So you can say you should not do that, but people are people. That's the problem. And killing everybody is an option, but that's not a workable option, I think.
But the question is, how can one, let's say, design the procedures so as to ensure that such an adjustment is carried out, let's say, not in the way that was shown as giving bad results, that is with let's say low wobber and
what I tried to say, that was basically my last slide. If gas supply companies provide the information of the actual gas quality, that is on the actual Wolbe index and the actual hydrogen, then people can deal with that.
Correct.
That will require, in some countries, a change of legislation, but legislation can be changed overnight, so that's easy to do.
Okay, thank you, Mindert. There are more comments or thoughts on this. I think Mark was first. Mark, please.
Yeah, I wanted to support entirely what Mindert had said there. In the UK, the current situation is that you should not adjust the boiler, and most modern boilers have red paint on them, unless you actually call the manufacturer's hotline to, if you like, confirm with their hotline that you know what you're doing. Mm-hmm. But to even do that, you have to know what's coming down the pipe. If you don't, you're in a very difficult place. You're certainly in a difficult place in the commercial and industrial sector because of energy efficiency. So I thoroughly support Mindert's viewpoint that it really yes, we have to go to some sort of declaration, online declaration of Wolbe index and hydrogen content.
Mm-hmm. I think that that kind of information is indeed important. Jörg?
Yeah, I also wanted to support that because, first of all, we have done the surveys both in Germany and as far as I know also in France, where we have much higher figures than just 50% of all appliances being adjusted on site. I think in Germany we have more than 80%. In France it was something like 75 in one region of France. So we just know that it happens, and so. In many ways, adjusting to a reference gas is a theoretical exercise because at the end of the day, you have to work with the gas that you're given. And in this context, the idea that came up in the sector forum gas to have a classification scheme which tells us with a certain reliability what the expected gas quality is going to be for a certain amount of time, and to adjust for this gas would actually would be a benefit in that regard.
Yeah, I agree. I think maybe we should not discuss too much the on-site adjustment, because I think we all agree it's not only with the introduction of hydrogen, by the way, also if we are looking at wider WOBE index bandwidths, as Mindert called them. So I think then it is becoming more relevant. So it is an important topic. I think, Dave, you are next.
Yeah, yes, I'd hate to sort of go over too much on the field adjustment, but there are two main concerns that I have. The first of which is well, I don't know exactly what the situation in Europe is going to be, but certainly the UK has legislated for zero emissions, zero carbon emissions by 2050, and so that has huge implications for the nature of the gas distribution networks. And so one possible scenario that's being envisaged is essentially either pure hydrogen networks, and either networks comprising biomethane plus up to 20% hydrogen. And that immediately poses a number of problems, the first of which is that you can't always add 20% hydrogen to biomethanes. Typically, they have much lower WOBE index, so they might be 47.3 or something like that, or they might go up as high as 49.85. But essentially, that means you have potentially sort of very, very little hydrogen addition possibilities, maybe 1 or 2%, maybe up to 20% for the higher WOBE index, and that's governed largely by the inert content of the biomethane. The other problem associated with such a scenario of large quantities of biomethane is that Mindert's suggestion of adjusting field adjustment based on oxygen, which is an extremely good idea when you have zero oxygen natural gas, but with biomethane being permitted to have up to 1% in many countries now, that also will skew the manufacturer's instructions, because like they do now, they have to make some assumption when they give guidance on CO2 content. They will have to make some assumption about oxygen content in the natural gas or biomethane matrix to which you're adding the hydrogen.
Okay, yeah, thank you. Very interesting. I've also noted that. Thank you, Dave. Howard, please.
Yeah, thanks, Chris. I'd like to make a remark about Mindert's presentation. I think the Mindert's suggestion of having both a range of hydrogen for appliances and a range for WOBE index, I think that really appeals to me, particularly for the reason that having the range of WOBE index specified that gives you the range of equivalence ratio in your appliances. And as I'm sure Jörg Leitner would say, that would inform you that the range of equivalence ratio automatically translate to a range of burning velocities. And you will already know then what the range of burning velocities is for your appliance with natural gas, and then you can put the effect of hydrogen on top of it. So I think this is a really handy way of looking at the problem. Thank you.
Okay, thank you for your statement. By the way, I think because there are some combustion specialists present here, so I also like to refer to another deliverable we have already produced in the THyGA project. So it's deliverable 2.2, if I'm not mistaken. So on the impact on combustion processes. So I think personally it's a good report. I can say it. I didn't write it myself, so I think I can say it. So, and it's publicly available. So please, I think it's also interesting to have a look at that. Noureddin, you have a question or a remark?
I have a question for Mark. How leaks are tested in Kiel's university? for old boilers and appliances?
Simple tightness tests. So you get at them. You go to a point and pressurize to the system pressure, and then wait for 2 minutes, 5 minutes, depending on what the standard says.
Okay. I thought you were using just soaped water.
No. Those are proper drop tests. Oh, sorry.
Okay.
They're no longer called drop tests. That time shows my age. The tightness test.
Okay. Thank you.
Okay, thank you. Okay, I see there are no more hands raised for the moment. I have one question myself still to Mindert. About what he thinks about introducing, because I've also seen that in Maurizio's presentation, Maurizio from Electrolux, who is also, could it be an idea to introduce a hydrogen concentration on EU level rather than on a member states level, and why not do that quickly? So to avoid that new appliances are still put on the market. They are there for 15 years, 20 years maybe or more sometimes. Would that be an idea or not? That certainly is an idea, but a good idea or not? Mindert.
It's an idea. It's a good idea. But usually the problem with good ideas, then you have to motivate other people to accept it. And that's where the real problem lies. Member states are independent on specifying their gas distributed. That's one of the limited rights they have. So that's one problem. And I think waiting for the member states to agree something will enable you to grow a beard, let me say it like that. So what I would say, if the appliance industry simply says we go for the 20%, this is a chicken and egg problem, and I think the chicken should be busy making just a statement, we go for the 20%, and then everybody will follow. Because waiting for the member states to agree on something like that.
Yeah. I think in the GAR there is one of the articles would, to my opinion, but I'm no lawyer, of course, allow the European Commission to introduce, to overrule in a way the member states there. But I think, okay, as it's also about member states in the Commission, so probably we'll be confronted to the same problem.
What I must say, frappé toujours, which is the only French I speak. So in the working group gas appliances, every time I am there, I'm asking the Commission and the member states to set a European level legislation or requirement, and they fail to move. That's the problem. That's not a reason to ask it again, but you have to keep on pushing. That's the only thing I can say.
Okay, thank you. I think Noureddin, your hand is still raised. You still have a comment to that, or?
I want to comment on the 20% hydrogen. I think it comes from a European project which was done, I think, between 2005 and 15 and 20. Sorry, 5 and 10, where materials used in the transmission and distribution network were tested with different concentrations of hydrogen to check their strength or resistance to hydrogen. And 20% was accepted for, I think, all materials. The project is called Naturally.
Yeah. Okay, thank you. But the way I feel it, or what I see from the discussions here, is that not 20% is that much questioned. It's more about, okay, where does it come from? How is it justified? Okay, Dave.
Thank you, Chris. One thing I would sort of urge those that are developing standards for appliances, when they consider a bandwidth of WOBI index or an expectation or whatever, that we went down the route when we were sort of looking in the early days of changing the WOBI index range for a harmonized European gas quality standard. That there is sometimes a disconnect between expectations of appliance manufacturers about what gas will be used to fuel their appliances and what gas distribution companies actually transmit in the reality. So I would urge that they familiarise themselves with the activities of TC234 WG11, which is currently has proposals for revision of the harmonised natural gas standard, which is EN 16726. And you'll see under there that it's likely that they will have an entry point specification, and it's likely that there will be multiple exit point specifications. And so there is a danger that EN 16726 will enable gas transporters to set an exit specification, and thereby, if that is different to that that's applied by the manufacturers or the appliance manufacturers, then there'll be a mismatch, and I can see some real problems there. So it's quite a complicated situation.
Yeah, I understand your point. I'm also quite closely involved in these discussions, or I was at least. Yeah, I agree on that point. But maybe we should not, because it's a little bit independent from. It's not only linked to the hydrogen injection. I think it's wider than only linked to hydrogen injection. But I agree on your point. Mark, you were next.
Yeah, just to, there's quite a lot of enthusiasm from particularly the HHIC members to promote the sale on almost compulsory sale of hydrogen ready appliances, because that's a way they see of long-term defending the gas industry against total electrification if we're going to commit ourselves to substantial carbon reduction. And hydrogen ready will appear to have only very marginal effect on cost. And I just put it forward as something there which could be taken up and which there seems to be real interest in.
Yeah. Okay, thank you. Jörg?
I just feel obliged to point out at this that about 2/3 of the gas actually do not go to the residential and domestic sector. So when we discuss this, we have to keep in mind that we also talk about industrial gas utilization. We talk about power generation. So this is not a discussion that this group can discuss or, of course, not decide anyway. But we need to keep in mind that there are other requirements to gas. Other operations with gas, so this is not something that from an end-use side the residential sector has to deal with alone.
Yeah, okay, I agree too. The THyGA project is not about these applications, but indeed you are absolutely right. Okay, Andrea?
Yes, here I am. Can you see me? Yes.
Not yet, but we can hear you already.
Well, I was trying to be quick, but I'm looking for my turn.
Yeah, okay, it works. Thanks.
So good afternoon, everybody. Yeah, I have not really a question, but maybe a comment on this, because as a manufacturer, we are trying to be very proactive to upgrade our product for hydrogen blend and also pure hydrogen, as my colleague Sebastiano presented. The roadblock that we see for the marketability of this such kind of product are mainly the legislation standard that are not following the same speed of the development we can take. So the problem that I see is that the hydrogen production is not enough for all the application. It's a fancy, it's a very cool target for Europe, and not only, but probably the quantity that can be produced, green, blue, is not enough for all. And the application, the most advanced picture looks for the use in transportation, for industrial application, but not for heating and other part, which is a pity because it's a strong contribution of decarbonization. So listening today workshop is extremely interesting. All the standards and the technical commission are working at. I think it's strategical to speed up. Otherwise, we lose the momentum. And when the hydrogen will be available, we will be not considered. And probably we will pass in the second step. So my question is to all. It's only my opinion or it's a common opinion? So can we speed up the legislation standards? Otherwise, we are just, it's a never-ending story, let's say, in this way.
Yeah, I would support that, but okay, I'm looking in. I think Mindert wants to react, or because you're.
If you want to go somewhere, don't wait for anything. So don't wait for standards. If you want your product as a manufacturer to be ready for 20% of hydrogen, get a certification for it. There's no barrier whatsoever. And if you want to do 30%, that's also possible. You can simply move forward. If you want, standardization is basically history. So what you find in the standard was the technology of 10 years ago. If you want to move ahead, don't comply with the standard, comply with the legislation. That's the only quick way forward.
Thanks for your it's exactly what we are doing. The risk is that we are not considered enough at the large level. So instead of to invest €1 million to extend the production, we are obliged to hold on, even if the development is done, even if the certification can be done. Mm-hmm. And we have already. Anyway, thank you very much for your answer.
Yeah, but I think that indeed I also agree. But I think it's also a legislation where it's important to okay, we were looking, for instance, to the GAR and the concentrations that are communicated by the member states, and eventually harmonizing that or introduce it these concentrations like 20% as soon as possible, because okay, you can as a manufacturer work on your products, but if the other products are not ready and if the market is not ready, then maybe authorities will have or will choose for other options. Okay, I think that brings us to the end of the meeting. So we'll have about 10 minutes overtime. I think that's still acceptable on 3.5 hours. So that brings me to the end. I would like to say that I think we gathered, or at least that's my feeling. I hope that it's shared by you, that we gathered valuable information. It's good to see that different initiatives are taken and are going on the different levels, as well as on the side of test conditions, test gases, etc., but also on the product side and also on component side, which I consider also very important, with control and safety devices having an essential role to play, of course. So yeah, I repeat that it concerns, because it has been stated by Michel in the beginning also, and I think it's also important to say that the presentations, or some of the presentations, it's about ongoing work, not necessarily approved according the processes defined to do so, to decide to get final approval. But I think it is interesting. It has been interesting very in any way. So there are a few points. I will send some conclusions, takeaways in Telegram style of the workshop today. So there are some open issues. Of course, there are, I think, about on-site adjustment legislation. But okay, that will be tackled in the conclusions or takeaways, main takeaways. I will send to you all. I think it's also one major conclusion of today is clearly that there is I think the most important problem is the fact that it seems to be a very male or masculine business. There are hardly not even 10% women participating today. So that is an issue to be tackled, maybe the most urgent one. So there will probably be a second workshop later this year dedicated to, well, this topic certainly, but also maybe combined with some other topic, and then it will be public because there is a lot of interest, I think. So okay, that brings me to I will thank you, but I don't know, Mindert, you wanted to say something, or because you not so I want to thank you. I want to thank specifically Gert and Alexandra for the practical organization. Each of the speakers, of course, for preparing their input and to share that with us. A special thanks to Ted also to get up. Who has had to get up early this morning. So thank you. It was also interesting, Ted, and we will be in touch, certainly. And of course, all of you who have been there today, because it has been highly appreciated and my high expectations have been fulfilled. Thank you very much. Have a nice evening and hope to talk to you soon again.
Great job, Chris and Alexandra.
Bye-bye.
Bye.
Wow.
Bye-bye.
Thank you.
Everybody.
Goodbye. Thank you. Thank you, Chris. Thank you.
Thank you.
Bye.
Thank you. Bye-bye.
Goodbye.
Oh, nice music.
Bye, everyone.
Ready for you, Chris.
La traversière ou... Okay. Hiltrud, hi.
I cannot speak.
Why? I can't hear you anymore. You're muted, apparently. No?
Now I'm unmuted.
Yes,
It's
you are.
strange. Our system is since we are now having our telephone and everything via Teams and internet, it becomes more difficult.